please settle down as our event will start in a few moments. To our participants, please kindly mute your microphones, please. Thank you. To all of our participants, please kindly change your screen name into your complete name dash school name. Thank you. Okay, so we will start in a few moments. Let's just wait for the other participants. Okay, so hang on tight.
Napakadami kasi ano ito, mga bago. Bakit ba yun?
All right, so good afternoon to all of you. So may I invite you all to please settle down so we can start our event. All right, so for our invocation, led to us by one of our board of directors, Ms. Julie Ann G. Velasco, followed by the national anthem and the webinar etiquette.
Let us bow our heads and place our trust to God, the Son, and the Holy Spirit's Spirit. We praise and thank your name, Almighty and eternally loving God. You have lavished so many benefits on us, and your presence serves as constant reminder of your devotion and wisdom. We respectfully request that you pour your finest inspiration on our speakers today so that they may offer the best of their knowledge, their field of expertise, and their respective topics. May we also take use of these wonderful learning opportunities and put what we've learned into practice today. We want to be living witnesses of your true love through the application of the information gained through this activity and get to your boundless blessing for the success of this webinar. In the name of our Lord and Savior Jesus Christ, we pray for this.
Yan ang pambansang awit ng Pilipinas. Kayang mag-ibig, telas na sinakanan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyag ka ng mag-ibig, sa mandulupin, di ka pasisingil, sa nagatang tutok sa simoy at sa langit mong pangaw, ay hinatang tula, kawin sa pagkayang minamahal, ang isang ng patawad mo'y tagumpay na nag-iibig. Ang ituwin na pagya, kailan ang may di mag-iibig, luma ng araw ng wahabing pagsinta, buhay langit sa piling mo. Ang hindi kaya ng pagkay mga api, ang mamatay ng dahil sa'yo.
And now for our webinar etiquettes. So keep your computer, microphones, or phone lines muted during the session. Active participation is highly encouraged. All questions will be addressed at the end during the Q&A. During the Q&A, keep your questions minimal and on the topic. Okay, so change your screen name into your complete name dash school name. Sample, Juan de la Cruz dash DMMMSU-MLUC. So right now, while I'm reading this webinar etiquette, kindly please change your screen name into your complete name dash school name. All right, so at the end of the session, there will be a post-evaluation form. So the form must be completed by participants in order to receive an e-certificate. But though there's a quite change in this, so the post-evaluation form will be a proof of your attendance for today's event. Okay, in order for you to receive your e-certificate, you have first you have to like our FB page and subscribe to our YouTube channel. Okay, and that will be shown later. Okay, once again, the post-evaluation form will serve as your attendance for today's webinar. And for you to receive your e-certificate, you have to subscribe and like our FB page and YouTube channel. All right, so a reminder that this webinar is recorded. So yeah, so good afternoon to everyone. And now we're going to have the acknowledgement of the other student units or schools. So like yung mga dating gawe, if you see your school logo, please show your activeness in your school or your participate kung gaano kayo ka-active sa inyong student unit. Or if you have a campus cheer, much better. You can drop it down below sa ating chat box. And you can, pwede din kayo magsabi ng mga shoutouts nyo or anything that you like. As long as it's not rude or causes any violations, then you're good to go. All right. And a reminder that this is also a national webinar, so we'll be having a lot of participants all around the Philippines. So let's acknowledge those student units, universities, colleges, and schools. All right, so let's begin with Luzon. Okay, so our schools from Luzon are Addison University, Bataan Peninsula State University Main Campus, Batangas State University, Bicol State College in Applied Sciences and Technology, Bicol University, Camarines Norte State College, Camarines Sur Polytechnic College, De La Salle University Dasmariñas, Don Honorio Ventura State University, Emilio Aguinaldo College Cavite Campus, Golden Gate Colleges, Holy Angel University, Laguna State Polytechnic University Santa Cruz Campus, Lyceum of the Philippines University Cavite Campus, Lyceum of the Philippines University Batangas Campus, Malayan College Laguna, Manuel S. Varga University Foundation, Mariano Marcos State University, La Dacia University of Science and Technology, Basilan State University or the Neta City Campus, Dinman University of Batangas, Polytechnic University of the Philippines Alfonso Campus, Polytechnic University of the Philippines Maragondon Campus, Romblon State University, St. Louis University, Sorsogon State University Main Campus, Southern Luzon State University, Tarlac State University, Technological University of the Philippines Cavite, University of Batangas, University of Nueva Cáceres, University of Perpetual Health System,
Recording in
Tunelta
progress.
Denan Campus, University of Rizal System, University of San Carlos Talamban Campus, Westmid International School, and now from the NCR, we have the Colegio de Muntinlupa, Pineo Amang Rodriguez Institute of Science and Technology, National University Manila, Pamantasan ng Lungsod ng Maynila, Polytechnic University of the Philippines Manila, Technological Institute of the Philippines, Quezon City, University of Perpetual Health System, Delta Calamba Campus, University of the East Manila. And now from Visayas, we have the Capiz State University Main Campus, Central Philippine University, Eastern Visayas State University or Moc City Campus, Eastern Iloilo Science and Technology University Main Campus, Negros Oriental State University, Suliman University, University of Antique Main Campus, University of Cebu, Lapu-Lapu, and Mandaue. University of San Carlos. University of San Jose Recoletos. Visayas State University. Western Institute of Technology. Western Philippines University. And from Mindanao, we have Ateneo de Davao University, Central Mindanao University, Green Valley College Foundation Incorporated, Mindanao State University Marawi Main Campus, University of Mindanao Main Campus, University of Southeastern Philippines, Western Mindanao State University, and from our home school, Don Mariano Marcos Memorial State University, Midla Union Campus. Alright, so mukhang kailangan pa ng pang-start ng afternoon ng ating mga students. Okay, so tayo mag-alala, magigising kayo later on. Okay, so ang nakakita ko pa lang na nag-shout out is from URSM. Okay, so saan kayo? There you go. Okay, so again, sa ating mga past webinars, you probably know me, but I will be introducing myself again. So I am Maria Erica Macy Santa Ana. I am the PSME DMMMSU-MLUC Student Unit Treasurer, and I would be your Master of Ceremony for today. Okay, so it is a privilege to welcome you all in our national webinar with the topic of mechanical ventilation design process and mechanical design in product development industry. So without further ado, let us start our program for today by opening remarks of our PSME DMMMSU-MLUC Student Unit President, Mr. John Bell Ardelizo.
Good afternoon, Erica. So our research speaker, Engineer Adrian Nakasakit II, and Engineer Claus M. Arriola, our ever-supporting advisor, Engineer Thelma Teovilio, our participating student units from various schools, our members and professors from our beloved university, DMMMSU-MLUC, visitors and guests, and my fellow PSME DMMMSU-MLUC student unit officers, a pleasant afternoon to all of you, and thank you so much for taking the time to join us today as we accelerate the exchange of ideas. It gives me immense pleasure in welcoming all of you to this webinar.
Press, sorry to disrupt, but your audio is quite...
Okay. Please allow me to check my audio.
Alright, so I think kailangan pang ayusin ang ating audio, ang audio ng press. So he'll be back in a few minutes. Okay, but before that, let's proceed na lang sa ating program. So, may I see ang sa mga students if you're there? Okay, so I'm seeing Go UE. Okay, tapos may nakikita pa ako dito. Hey guys, you can drop anything. Hello everyone from Sorsogon State University, from Aldrin. Hello, good afternoon, and Go DMMMSU. Yes, hi Kuya Xavier. Okay, so we have Kay Leslie. So good afternoon po from SSU. Okay, so go guys. Arriba, WMSU. Okay. So kung makita kung gaano ka-active ang ating mga students for today's webinar. Okay, from CAPSU. Nandun tayo dito from Apas Christine. Okay, good afternoon po ulit from University of Rizal System, Morong Campus, from Agustin. Okay, so DMMMSU. Okay, and we have Emmanuel Go DHVSU. Okay. Meron na tayong mga dyan, at least, di ba? We're being active today. So good afternoon from Camarines Sur Polytechnic College. From Anjanette. Okay, from University of Antique. Kay Edrelyn. Okay, we also have the DHVSU. Laang daw ang sakalam. Guys, paano ba kayo nun? No, I'm just kidding. Okay, I'm just kidding po. So, yeah, well, good afternoon. Yun, so, college, Sorsogon State College, Tarlac State College, CPEC. Okay, so, parang parang Capiz State University. Okay, guys, padami na nagiging active sa ating mga students. Okay. Meron na tayo from Bidcast, Camarines Sur Polytechnic College. Okay, guys, huwag kayong magpapatalo.
Recording stopped.
Okay. Soar High Adamson Falcons by Keith Arvin. Okay.
Recording in progress.
Okay, so I think our president is ready now. Press, can you do a mic check or an audio check? Naka-mute ka, Press. Kindly unmute pa. Yeah.
Sorry for that. Is that audio okay now?
Medyo kulog pa rin, Press.
Okay.
Okay, all right. So, inaayos pa yon. Inaayos pa rin. So, yun. So, may nagtanong sa akin, if ever, kung hindi daw nakapag-register, pero is still here, still present here. Okay, as long as you fill up the post-evaluation form later, that will serve as your attendance for today. And sabi ko nga kanina, just fill up the post-evaluation form na available mamaya, and because that would be a proof of your attendance. Pero in order for you to receive your e-certificate, you just have to dapat makumpleto mo yung tatlo. Okay, so post-evaluation form, you have to like and follow our FB page and subscribe to our YouTube channel. Yun lang. So, if ever na ano kayo, na na-delay kayo sa pag-register, no worries. As long as you're here, as long na umattend kayo, then it's okay. Andito naman kayo para mag-participate. Okay, so habang inaayos pa ni Press ang audio niya, let's balik ulit ako sa ating mga shoutouts. Okay. So, meron din tayo from good afternoon to all from the Western Philippines University by Michael. Okay, meron din tayo kay Angelo from National Teachers College. Okay. Hi, from Rizal Technological University from Danica. Meron din tayo from Addison University. Okay, Sorsogon State University. Nakakarami na mga Sorsogon ha. Sorsogon State. Very active ang inyong mga students. Okay, good afternoon kay Jeneline Hias from URS Morong. So good afternoon po from Bataan Peninsula State University Main College by Lysel. Okay, shout out po kay Krista Joy Petalio from CSPC by Marla. Okay, saan pa tayo dito? From Adamson. Okay, nakakarami na din ng Adamson ha. Okay. Let's go. Okay, nawala. Yun. From EVSU OCC. Okay. Okay, dumadami ng ating mga... Grabe, nagiging active ng ating mga students. I like that. I like that. Keep that energy up ha. Marami pang mangyayari mamaya. Okay, take your time, Press. Okay. So yun. So meron pa tayo dito 111 new messages and comments So I can really see na napaka-active natin mga students. Shout out from Capiz State University, from Karen. So good afternoon from Sorsogon State University. Wow! Grabe Sorsogon! Parang wala pa ako nakikita dito dyan. Ang unti ng mga dimso. Dimso, nasaan na kayo? Gising! Huwag mo papatalo. Hindi, joke lang. Hindi, just a kids. Okay, so good afternoon from Pamantasan ng Luzon, Maynila. Okay, from Juvenmar. Juvenmar. Okay, sorry about that. Okay, so good afternoon from St. Louis University, from Judy. And, okay, we're gonna go down, okay? We're gonna go down. There's a lot. There's shout out from University of the East Manila, Camarines Sur Polytechnic College. All right, so we have a raise of hands. Sino yun? Okay, wow. And the comment section just keeps going. From Bicol State College of Applied Sciences and Technology. Okay, ito na. Nabubuhay ng ating mga schools. Okay, so we have from Technological University of the Philippines, Taguig, Tarlac State University. Okay, we have some sa Capsule, the Bicol State College of Applied Sciences. Okay, so we have John R. Mapagdalita, BT Mechanical from Sorsogon State University. Go Bibcast! Okay, saan ang mga taga-Bibcast dyan? Okay, so yun. So may nag-raise ulit sa akin ng question. Baka ito yung mga latecomers about sa registration and from receiving the e-certificate. Well, ulitin ko naman ulit yun sa end of our event, okay, ating program. So no worries, okay? You don't have to worry about that. Okay, good afternoon po from SSU Main Campus. Can you please send the link of your YouTube channel? Thank you. Okay, magpapakita po yan later. We're just gonna we're just gonna drop the the channels and the FB page down below, and it'll be available later, so don't worry about that. We just have to proceed with our event. Okay, Tarlac State University. Okay, we have good afternoon from Bicol State College of Applied Sciences, Padayon ME students. Yon, that's the spirit. Let's go ME students. We are all ME here. ME here. Okay. So yun po, may tanong po tayo. So good afternoon po ma'am. Magkakaroon po ba kami ng e-certificate kahit hindi po kami nakapag-register po? Again po, I will explain that again later. Pag i-explain, let's just proceed with our event po muna. Okay. Press, nadyan ka ba ba? Are we all good? Are we still going? Is your audio okay na, Press? Okay. Well, I guess still fixing. So, parami ng ating mga participants ha. And parami pa rin ang ating mga comment section. That's nice. Okay? Ang dami mga active. Okay, stay tuned. Okay, stay tuned mamaya. Kasi magkakaroon tayo ng mga games. Yun lang, games. Mas makikipag-chika ako mamaya. Yes po, po to? Webinar na may chika. It's very unique. So, if you're here, you can also have fun, and at the same time, you can be educated, kaharon ka ng new knowledge about a deeper understanding about other topics, advanced topics, alright? So, pero, syempre, hindi pa rin natin pwedeng walain doon yung pagiging jolly natin, di ba? Kailangan pa rin naman natin yon, okay? So, shout out po kay Justin Marby Manao and Shaila Magalona from SCPC. Okay, from Marla ulit. You have a lot of friends. That's nice. Let's go. Let's go. Go ME students and teachers, professors. Yes. I like that. Oh, the obvious energy, no? Sorry about that. Okay. So, what's the... Oh, oops. We are having 203 upcoming messages. Okay, shout out po sa Western Philippines University. Let's go. Yeah, let's go, guys. Western Philippines, Sorsogon State. Madami ng Sorsogon, ha? Pero feeling ko marami pa akong na-miss. Kaysa sa LPU, Batangas. Shout out po kay Mark Lenyo. Okay, from our... Okay, so sadly nagkaroon talaga ng technical problem or nagkaroon ng audio problem talaga si Press. So I think I would call on Okay, so may I ask our Vice President of Internal Affairs if you're good to go?
Hello. How are we going now?
Who's talking po? Wait po. All right. Excuse me po, pero who's talking po?
Hello. Can you hear me?
Yes, clear. Oh, hi, Press.
Okay. So I'm really sorry for that, but let me welcome you. So our dear speakers, Engineer Adrian Makasakit II and Engineer Claus M. Arriola, our ever supporting advisor, Engineer Thelma Teovilio, our participating student units from our various schools, our members and professors from our beloved university, 𝐏𝐡𝐢𝐥𝐢𝐥𝐢, visitors and guests, and my fellow PSME 𝐏𝐡𝐢𝐥𝐢𝐥𝐢 student unit officers. A pleasant afternoon to all of you, and thank you so much for taking the time to join us today as we accelerate the exchange of ideas. It gives me immense pleasure in welcoming you to this webinar, and we are really grateful for your presence today. And we are really delighted that once again, we are here able to meet virtually after our 5 previous successful national webinars to learn from the insightful discussion and presentation of our beloved speakers. So during this COVID-19 pandemic, everything have become so difficult. And so is conducting webinars like this. However, we are really determined to organize these webinars because we believe that learnings doesn't stop whatever may. And our presence today just goes to show that we are really so eager to acquire new learnings, new knowledge, and new learnings about these fields of mechanical engineering. In addition, it is really overwhelming to see how many participants from more than 65 universities here in the Philippines are present today and joining us. And by the end of this webinar, may we feel enriched with knowledge that would surely be helpful in our future careers. So on behalf of our student unit, I would like to thank our dear speakers, Engineer Makasakit and Engineer Arriola, for accepting our invitation without any hesitation. And I would also like to thank all our participating student units and schools for being here with us today. And I would also like to thank the PSME National Secretariat through Engineer Baril and Engineer Christopher Casino for assisting us in the problem that we have encountered a while ago. And also to my fellow PSME 𝐏𝐡𝐢𝐥𝐢𝐥𝐢 student unit officers and to our volunteers who are really eager to help us. Thank you so much for your hard work that made this webinar possible. So once again, a pleasant afternoon to everyone. Thank you so much for being here and I hope that we will all have a great time ahead. So once again, thank you so much and enjoy the webinar.
All right, so thank you, Press, for officially opening our event. And now, sabi nga ni Press that it's going to be exciting. Okay, may I, again, can I remind everyone to please mute their microphones? Okay, but thank you. And also, sa exciting part, okay, so we're reading about sa mga comments and suggestions na sa ating mga Google form, sa Google form. So, we've listened to it, and yung exciting part today would be hindi lang magkakaroon ng one speaker, kundi magkakaroon ng dalawa tayong speaker for today. So, let's name those two. Okay, so sino nga bang ating mga speakers for today? So, our first speaker would be Engineer Klaus M. Arriola and Engineer Adrian S. Makasakit. Okay, so our first speaker for today is Engineer Klaus M. Arriola. So he is the current Senior M&E Engineer of the Bescon Consulting Engineers Private Limited in Singapore. He became the President of the Philippine Society of Mechanical Engineers of the PSME 69th Singapore chapter in 2019, and he is the current chapter's advisor. So he is a regular member of the American Society of Heating, Refrigeration, and Air Conditioning Engineers of ASHRAE. So presenting our first resource speaker for today, a Senior M&E Engineer of Bescon Consulting Engineers Private Limited. Let us welcome Engineer Klaus M. Arriola.
Hi. Is my audio clear?
Yes, sir. Loud and clear po.
Yeah. Can I be able to share my screen?
Yes, sir. Thank you.
Hold on for a while. I cannot share my screen.
Wait lang po, sir.
Yeah,
we're
sure.
Yes po.
Isama kasi brother.
Sir, okay na po. Pakitry po.
Okay na.
Apo. Pwede po pakitry po ulit mag-share.
Yeah. Hold on for a while. Okay, can you see my presentation?
Yes po, sir.
What do you see? Is it the full screen presentation or the presenter view?
Whole screen po.
Yeah, very good. Okay, shall I start now? Do we have an audience who is a foreigner? Or is it all Filipino?
Filipino po, sir.
All Filipino, okay.
Yes po,
so,
sir.
Okay, so maybe I will speak in Tagalog, in our native language, and also sometimes I will speak English. So it will be a mix of language. So I hope you don't mind. So good afternoon. it's been an honor to be here, students, to share with you our knowledge, knowledge in our industry, and also to share with you or to impart to you or to transfer the technology from abroad to back to Philippines. This is our goal. Really, what we are doing here right now is to you guys be more good. Gusto namin mas magaling kayo sa amin para in the future it will be better for our country, and it will be better for the future generation of engineers. And the future, if of course engineers are part of the community, if you will do good, you'll practice better for our country, then it will be better for all. Okay, without further ado, shall I start? So this is a mechanical ventilation design process. My so there are individuals that is very keen to go for design. Okay, there are some are keen because mechanical engineering is so broad. You can go consultancy, you can go design, you can go manufacturing, you can go in R&D, product development, which will be presented by Adrian. And then you can also go for construction, which I will be presenting right now. Okay, so this is a simple mechanical ventilation discussion. So I will not to be very complicated because air conditioning and mechanical ventilation is a broad topic, and it can be complicated sometimes. But for you guys who are some of you are third year, may I know who are those third year standing? How many? Can you raise hand? Oh, by the way, I want all of you guys to participate, or else I will call you. Those who are not participating, I will call your name. So better be listen. And also, at the end of the discussion, before you will get your certificate, there will be an evaluation. There will be a quiz. Okay? There will be a problem solving. This one will also make you confident in designing. Say, sir, design po yan. Design. Oh, maybe I cannot have this, I'm not fit to it, or maybe I'm not good in school. So maybe design is not for me. No, you're wrong. Design is so simple. It's just that you need to understand what's the fundamentals and what is required and what is the process. So madami tayong third year, okay? That is why I will ask, because I want you to understand. I will make it more basic because some of you, if you have not yet tackled heat transfer, if you have not yet tackled thermodynamics 2, some of you guys bagsak sa thermo 1, di niyo pa makakuha yung thermo 2. So, I want to make this topic more simple, okay? For you guys to say, to give you that stigma na hindi mahirap ang design. And also, Philippines need more design engineers because we are developing country. We are a developing country, and also I don't want you guys. I'm very very happy that here we have students from provinces, Visayas, Luzon, Visayas, and Mindanao, which is I'm very excited because I don't want you to, alam mo yun, I want you to guys not to be able to transfer to Manila because Manila is so congested. So if you know how to design, maybe you can, if the other engineers have local companies, then you don't have to migrate to Manila, right? So if you have the knowledge is powerful. Okay, so without further ado, design is not difficult. You just have to listen. So after this, there will be a quiz, so you have to listen, guys. Okay, Okay, what is the seminar outline? Okay, so we will tackle the usage of ventilation. We will have different calculation methods of mechanical ventilation. What are the type of mechanical fans? What are the duct system design? How to have fan static calculation? How can you select your fan? And what is the silencer, or what is acoustic calculation? We have smoke ventilation, and here, let's go to usage of mechanical ventilation. Guys, what is mechanical ventilation? Mechanical ventilation is, the concept is that you will need to ventilate a space in a mechanical manner, or wherein you will have a machine to ventilate this space, which is more we will be tackled in your industrial engineering or industrial mechanical engineering on your 5th year, which is the fans or blowers. Okay, I think there is more in the waiting room. Can you assist, admin? Okay, so what is the usage of mechanical ventilation? Okay, you need to ventilate or occupancy ventilation. Ito, kailangan ito because why? Not all spaces in your building are air conditioned. Okay? Bakit? Because there are things that, of course, air conditioning is very expensive. And then if it's not really necessary to air condition the room because it's not really always used, sometimes it just used intermittently or not all the time, then maybe mechanical ventilation is a better choice. Okay, so it's occupancy ventilation. Okay, so you need to have good air quality, okay, by having air change or purging. What is purging, sir? Purging is purge. Tinutulak yung hangin from, or the used air or lumang hangin from the room, then pinapalitan ng bago. That's what you call purging. Okay? Then, of course, comfort. Because if, let's say, in a space, you don't need to make it very knowledgeable in thermodynamics. It's just common sense. If you are in a space, then tas may hangin na paparating, it will give you more comfort kasi it absorbs the moisture of your body out from your body, then it will bring, and then it transfer the heat. Okay, for you guys, transfer the heat from your body to the atmosphere. So it will give you comfort. Okay? This is ngayon na application na to. Okay? For you to understand your subject, what is the practical application? Okay? So I'm now teaching you the practical application of your fundamental curriculum in what you learn from school. Okay? So next is asset protection. So in asset protection, what is asset protection, sir? These are the things that in mechanical ventilation, it also protects the machine because some machine generates heat. And then if the machine generates heat, then it will be more, some machine makes, if it exceeds the limit of the design of the machine because of this heat, then the productivity or the efficiency of the machine might decrease. So you need to ventilate the room space. So the temperature of the space or temperature in the space where the machine is located will not increase to the limit, to the desired limitation. Next is extraction of heat. Okay. So like I mentioned, this one are the heat transfer, taking out the heat from the space out to the atmosphere. Okay? Ako na nag-add admin ha. Okay. Next, life safety. Okay, life safety. Sir, ano bang life safety? Bakit? Kasi alam nyo ba, pag may mga sunog, di naman aircon ang papatakbo. Di mo kailangan ng aircon. Kailangan mo ng mechanical ventilation. Sino, can you raise down your hands? Okay, raise down your hands. Sino nakabalita dun sa Resorts World accident? Okay? Few years back, there is a Resorts World accident because a crazy gunman set the Resorts World on fire. Then they have thought it's a terrorist group, but it's not. It's just a single man individual who set the casino on fire. And then some of the occupants died not because of fire, but because of smoke. Okay, so mechanical ventilation is very important for the people or the occupants of the space to go to the vestibule or the safe access or safe place. Right? In the building. There are some safe place in the building which is will be protected from fire. Okay? So life safety is very important. So we have smoke extraction system, smoke purging system, which is push the smoke away from the vestibule space or protected space. And we have clean gas extraction system. What is this clean gas? I will explain later. Okay. Then of course we have, you can raise down your hands, guys. You have operation. Okay. So operation, we use mechanical ventilation in laboratory fume hoods and kitchen ventilation and hospital. Why, sir? Because in operation, laboratory, that's very important because like for you guys, even we are mechanical engineers, we have Chem 1 and Chem 2. So this one, we are dealing with chemicals. So sometimes chemicals generate chemical reaction, which generate fumes. Then these fumes must be extracted by fume hoods. Okay. And then with the COVID situation, now laboratory is very essential. So this, if you know how to do mechanical ventilation, then you can be a part of design team for laboratory, especially who will help to fight this pandemic, to generate more vaccines. Then kitchen ventilation, because kitchen ventilation, you need grease. Kitchen ventilation, what is present to kitchen ventilation? What's the present in kitchen? Okay? Grasa, mantika, grease. So, this grease is very, will create trouble to some machines and also create accidents because it will make the space greasy, diba? So yun. So hospital, and then because you need to, some hospitals have requirements to have a clean air inside the room. So you need mechanical ventilation also, not to spread the virus from one space to another. Okay? Okay. Guys, if you have any questions, you can interrupt me, okay? Or if I'm making, I'm presenting the topic too fast. Okay? Later, you will have examination. Okay, sir, what are the different calculation methods, okay, in mechanical engineering? Is it hard? Okay, I tell you it's not. Okay, so we have air change. Okay, then what is air change? Okay, Erica May Santa Ana. Can you open your cam?
Yes, po, sir.
Can you read what is air change? Can you
Sir?
read? Yeah. Can you read what is air
Okay.
change? Yeah.
Okay, so by air changes, what is the air changes per R? So according to the ASHRAE 62.2 R is a measure of the air volume added to and removed from a space, normally a room space or house, divided by the volume of the space in 1 R.
Okay, what do you understand on that?
To be honest, sir, um, hindi ko po kasi alam. Hindi ko po
Okay,
masyado alam.
I'll help you on that. Okay, so basically, guys, it's the measure of it's the measure of changing the air on a space. Okay, because volume. What is volume? What is volume? Arian Jade Constantino. Oh, basic to ha, mga basic yan ha. Arian Jade Constantino of PSBC. Oh. Ba't mga iba walang school? Ha? Hindi nasagot si Arian Jade. O si Nika Medel Semira. What is volume? Hello? What? Nawala. Wait lang. Si Raul Deonida. What is volume? Raul Deonida. Wala kang school ha. Mga iba ha, palit kayo ng pangalan. With the school. Ha? There's no participation. Malungkot naman to. Okay?
Sorry, I can't help
Let's go. Anyone? What is volume? What
Sir?
is volume? Who's this?
Sir,
Who's this?
Joel Christian Viernes po from DMMMSU-MLUC po.
What's volume?
Sir, volume is the space that occupies by the mass or by an object po.
In mathematical, what is volume?
It is, wait po sir.
Area
Dami.
times height.
Dami.
Area times height. Yun lang ang volume, guys. Guys, yun lang ang volume. Area times height. Okay? So, you have a space. You have an area. You have a room. Let's say it's a room. You have an area. And then you have a height. Okay? It is the air change is the measurement how many times you change the air inside the room, okay, in 1 hour. Do you get it? Let's say you have 100 cubic meter of air inside the room, okay? Then how many times you change the 100 meter cube of air inside the room in 1 hour? Kuha? Nakuha ba? Okay, raise hand pag nakuha. Raise hand, nakuha ba? Raise hand. Okay. So, ganun lang air change, guys. Napakadali, di ba? So, yun yung, that's a very important thing because this one will have a formula because the ventilation rate is equals to the volume of the space times the air change per hour. It means the ventilation rate or your airflow will be equal to the volume of your space times the how many air change you want to change per hour. But this air change sometimes is coming from codes. What is the code? Later, I will explain. Okay. Code, okay, or regulation depends on the location. So, ask yourself first, you're a design engineer. Where is the location of your project? Okay? Because where is the location of your project, you need to follow the code requirements. Okay? In Singapore, which is I am located, we use this code. which is the SS553, wherein this is the air change. Let's say, for example, in offices, in 1 hour, I need to change the air. Kailangan, o tatagalugin ko sa loob ng isang oras, kailangan kong paano mag-change? Kailangan kong palitan. Ayun, palitan. Kailangan kong palitan yung hangin sa loob ng kwarto ng 6 na beses sa isang oras. Napakatagalog nun, ha? Nakuha ba? Oh, nakuha ba? Raysan, nakuha ba? Okay, so napakasimple, di ba? O yan yung design, di ba? So, sa restaurant, ilang beses mo papalitan ng hangin? 10. Sa mga retail, ilang beses mo papalitan? 6. Sa mga factory, 6 na beses. Sa workshop, sa classroom, 8 beses. Okay? Pero ito ay sa Singapore. Okay? Sir, paano naman sa Pinas? Okay? Okay, because Philippines commonly use ASHRAE, American. Okay? So, sa Pilipinas, I'm not sure whether you can see this. Okay? So, yeah, but can you see sometimes it's either air change or liter per second per meter square. So usually ito ay mga air conditioning, fresh air. Pero pag mga iba, ito ay outdoor air or fresh air sa air conditioning, which is, I think that is a different topic kung magdi-discuss, kung gusto niyo ako mag-discuss ng air conditioning. That's a different topic. Okay, let's go to these are the fresh air. Okay. These are fresh air rate. So you can see, madami, may retail, may sports, madami siyang wait lang, balik tayo. Ayan. So meron siyang liter per second and also meron siyang liter per second per person. Okay, these are the outdoor air rates. Galing yan sa ASHRAE. Pero meron din para sa mechanical ventilation. I think I will show it later in a separate after the discussion. Okay, so next. So na-discuss na natin air change. Next calculation method is by heat removal. So, sir, ano yung heat removal? So, di ba nasabi ko sa inyo, may mga makina na it will not work efficient, but if they have exceeded the design temperature for the space. Let's say, for example, mga servers, mga computers. Usually, pag kunwari umabot na ng 40 degrees Celsius, ang temperature ng room, di na siya, nag-overheat na siya, namamatay siya ng kusa, nag-shutdown na siya. So, just mind you guys, I think there is rumors that all those big servers, Google, Amazon, they want to venture here in the Southeast Asia. So they have started already in Singapore. Google have the biggest server here in Google, the company, have a very big server area or server center here in Singapore. So what is required? So sometimes mechanical ventilation is a backup. So if you have, these are servers, these are very expensive equipments. So if your chiller or your air conditioning fail, then they use mechanical ventilation. Okay, so what is required? Of course, the size of the motor or the size of the equipment. Okay, then what is the efficiency of the motor? Okay, then heat emitted is equals to size of the motor times efficiency. Okay. from the formula equals to airflow cubic meter per second is equals to heat removal divided by delta T, which is the maximum. Let's say, for example, your maximum limit is 40 degrees, and then your desired temperature is 24 degrees. So 40 degrees minus 20 is you have 20 times 1.2. So you can get cubic meter per second. That's the airflow that you need to remove the heat from the equipment. Okay? So we have ventilation rate. Q is the ventilation rate, and delta T is T room max minus T design. Okay, sir. So, paano yan, sir? So, for example, ito heat removal. So, makikita nyo dyan, guys. Ito ay generator. Generator ay ginagamit para in case of emergency. Pag walang power, then you use a generator. So, what are the things that you need to consider? Siyempre, the cross ventilation. Ang tawag dito, cross ventilation. Makikita nyo sa picture sa upper left corner is that the first picture of the box out of the four, the upper left, then you can see a very good cross ventilation. Ito inabsorb. May annotate. Can I annotate, admin? Admin, can I annotate? Can I annotate the screen?
Sir?
Yeah. Can I annotate the screen? Yeah, okay, can. Okay, can you see, guys? Kung makikita nyo dito, ito yung source ng heat. Source ng heat yan, guys. So makikita nyo, yung malamig na hangin, i-absorb niya yung heat, tapos, okay, i-absorb niya yung heat, tapos, ang lalabas sa outlet ay mainit na hangin na. Gets nyo? Gets nyo, raise hand? Okay? Oh, nakita nyo? Gets nyo, di ba? Napakasimple, thermodynamics. O, thermodynamics, heat transfer, convection na yan, no? Di ba? Napakasimple yung heat transfer. Okay. Okay, so, nakikita nyo dyan, guys. Okay, so, well, baba natin hands natin. So, makikita natin. So, yan. So, kung mari, dinesign nyo dito inlet. So, sa second picture tayo. Kung dinesign nyo dito inlet, oh, di ba? Pwede pa rin kasi dito yung outlet. Dadaanan pa rin. Dadaanan niya pa rin. Eh, paano pag kumari ito? Oh. Paano pag ito? Paano niya nadaanan yung generator? Di ba? So, walang cross ventilation. So, in section naman, nakikita nyo, mas maganda kung inlet. Ito yung section, no? Genset yan, no? Kita nyo yan? So, ito yung inlet, lower. So, i-absorb niya. Balta niya, no? I-absorb niya yung malamig na hangin. I-absorb niya yung mainit na genset. Tapos, ang lalabas ay medyo lukewarm na hangin. Gets nyo? Di ba? It's common sense, di ba? So, ganyan kayo dapat mag-design. You need to think. We are mechanical engineers. We are the greatest imaginators in the field of engineering because we can imagine how the air behaves. Okay? We can imagine the behavior of the unseenable. Diba? Kasi paano makikita yung hangin? Paano ma-imagine yung behavior ng air? Eh di mo naman nakikita, diba? O diba? ME lang sa kalam. Okay? Okay guys, continue. Okay, next. So, heat generated. Ano tayo ha? Malinaw tayo. So, next is kitchen ventilation. Kitchen ventilation. Wait lang And kitchen ventilation, we have from Singapore Code of Practice, because we have 1Q airflow equals to 1.4 times V times 2 times L plus W H F. So ano yun to, sir? Ibig sabihin, V is equal, ito yung capture velocity. So guys, sir, ano man pinagsasabi mo? Di ba? Kasi ito yung annotate natin, ha? Annotate. So ito yung guys. Ito yung kitchen hood. Ito yung kitchen hood, guys. Ito yung kitchen hood. So, kailangan ang objective is mahigop yung hangin na may mantika. Okay? Tapos, higupin ng kitchen hood. Usually, mga industrial, commercial, or industrial kitchen hood, ito, meron na dito silang mga filters na pinifilter yung mantika para pag exhaust nila doon is malinis na air na. Or yung tipong may mga kitchen hoods, industrial commercial kitchen hoods is ina-ionize yung mantika. So para bang paglabas ng hangin, wala na siyang mantika. Okay? So here you can see usually clear all drawings. Usually 0.3 for commercial kitchen or commercial type kitchen. Okay? Then the problem will give you the L. Okay? Ito yung L. Then ito yung W. Tapos ito yung H. Kaya tingnan niyo operation plus to. So pag plus mo muna to times 2 bago mo i-simulate tong isolve mo muna to bago mo i-times yun. Okay? So, distance of the hood, H, then F is the heavy duty, high temperature, and 0.7 is the light duty. So, depende yan. Kumari, sa tingin mo, heavy duty magiging space. Can you unmute? Okay. Admin, can please unmute? Sino yun? Si Renalyn. Okay. Yeah, yun. So F will be heavy duty. F is either heavy duty 1 or 0.7. Okay? Okay, next. Okay, sir. Bukayin natin to. Okay, sir. Ano na? Ano yung type of mechanical fans? Okay, guys. Sa mechanical ventilation, you can use either axial fan. Ito itsura. We have centrifugal fan. Centrifugal fan, which is from the word centrifugal. So, it's by centrifugal force or centrifuge. Okay? Then, we have cross-flow fan. This is the itsura. Okay? Pero ang cross-flow fan, hindi siya masyadong gamit or is not commonly used in the industry. Tandaan nyo yan, ha? Baka lumabas sa exam. Okay? Okay? So, meron tayong axial, centrifugal, and cross-flow. Tandaan yan. Tapos, blades. Okay. So, sa axial, types of centrifugal fans. So, you have the airfoil. This one, impeller design. You can have the airfoil. Okay, these are fan that is efficient and for pressure or static pressure. Sir, ano man static pressure? Static pressure is the force or the power of the fan to deliver the air from point A to point B. Okay? Isipin nyo, yung straw, di ba? Pag hihigop kayo, pag inipit nyo yung straw, mahirap humigop. Pero pag di nyo inipit, madaling higupin. Ganun din dito. May mga static pressure. So, mas mahirapan kayong humigop pag masyadong madaming pressure loss. So, ganyan din. Paghigop tsaka pag-blow or pagbuga. Okay? So, backward inclined or backward curve. So, nabago lang yung itsura ng blade. Okay? So, tapos meron siyang radial. Makikita nyo yung radial to width. Forward curve, kung makikita nyo, pa-curve siya, kaya lang pa-forward. Parang may sandok. Okay? Forward curve yun. Tapos, plenum plug, or ito pinaka-efficient, ito ay nasa may housing siya. Nakikita niyo to. So, lahat to ay nasa ASHRAE handbook. Fundamentals. Okay. So, example to ay ito yung backward curve centrifugal fan. Nakikita nyo kung paano paano siya mag-rotate. So, dadaan ditong hangin. So, dadaan dito siya hangin. Tapos, iikot siya ganon. Tapos, dito siya lalabas. Yan. Okay. So, punta naman tayo sa axial fans. So, sa axial fans, mas simple. We have the propeller. Okay. Ito, parang ano na to, simple electric fan. Makikita nyo to usually sa mga MRT o kaya sa mga toilet, makikita nyo yun. Propeller type. Okay? Yung parang electric fan lang. Okay? Axial yun. So, you have the tube axial. Ito ay meron lang siyang cylindrical tube. Okay? Parang siyang propeller, pero ito mas madami siyang blades. Okay? Then, the static pressure is much more higher than compared to propeller. Then, we have the blade axial, which is a good blade design, gives medium to high pressure capability and a good efficiency. This is the most efficient of the axial airfoil blades. Okay? Blades may have fixed or adjustable. Okay? So dito, meron din sang tube. Okay? Guide vanes, cylindrical tube with close clearance to blade tips. Oh, yan. Yan ang tube axial. Okay? Usually ito ginagamit namin sa Singapore kasi hindi maingay tsaka hindi takot sa space. Pwede mo siyang sa ceiling. Pwede mo siyang lagay sa ceiling. Okay? Tsaka hindi siya ganun katakaw na sa ceiling height din. Okay? So, ito naman ang not so common, not so used in the industry is the cross flow fans. Okay? It is a combination of axial and centrifugal. So nakikita niyo yung blades, parang siya, diagonal tapos may pa-curve. Okay? Kung makikita mo siya in section, ito yon. Dahil monitor. Ayan. Ito. So makikita mo in section, makikita mo pag ganyan siya. So ito yung blade. Ito yung blade, ito yun. Ito yung blade. So, ito top view, ito section view. Tapos ito naman yung cross flow tangential. Okay? Medyo weirdo lang sa space, ganyan. Tapos dito siya papasok. Yan, tapos pag ganun labas niya. Okay? This is not really common. I think this one is on special design manufacturing or tipong pag wala kang space, tapos or unconditioned yung space mo, ganon, magagamit mo to. pag non-conventional yung mga application. Okay. So this is the sample of the cross-flow plan. So makikita nyo, hindi siya even. Yung pasok niya, hindi siya parallel dun sa labas. Makikita nyo yung airflow na ganyan. Pag sinimulate mo sa CFD. So, sir, what are the things to consider? Okay, sa duct design. Sir, ano yung duct? Ito yung duct is the is like the highway or tipong daan kung saan dadaan ang hangin to deliver from your point A paglabas ng fan patungo sa point B o sa grill or diffuser. Okay? So what are the things to consider, sir? You have spaceability, routing, material, noise level, air leakages, okay, and balancing, and fire smoke control. So, syempre, may mga ducts, kuwari, di ba, sa Q, doon kanina sa formula natin, Q, ano dito, pag kuha natin airflow, okay, tapos, dito naman sa duct design, meron tayong ginagamit na formula na, dito ko susulat. Meron tayong ginagamit na formula na Q is equals to A V. So, A is area, then V is velocity. Okay? Ito ang ginagamit mo sa pag-design ng duct. Ito, airflow. Okay? May example tayo mamaya. Okay? So, powerful to mga engineer. Powerful to QAV. Kasi, ito ginagamit natin to sa pagdidesign ng duct, pagdidesign ng louver, pagdidesign ng diffuser or grill. Okay? So, pag maliit ang duct mo, tapos malaki ang fan mo, patay ka kasi meron kang noise level problem. Sisipol. Sipin nyo na lang na parang ang laki na binugan yung hangin, tapos ipit, di ba? Pag sa straw, nagbuga kayo ng hangin, tapos ipit. Minsan sumisipol yung straw, di ba? Pag nung kabataan yung nagawa natin yan. Tapos yung material. Sir, ba't kailangan ng material? Kasi may ibang duct ginagamit katulad sa kitchen. Ang kailangan mong gamitin is stainless steel. Kasi pag galvanized, masisira yun dahil panay mantika. So, ano pa ba? Air leakage yun. Pag marami kang air leakage sa duct manufacturing mo, o paano mo ginawa yung duct, masasayang yung hangin na sumisirit sa mga air leakage na yan. Tapos, siyempre, pag air leakage means money waste and energy waste. So, lalaki yung bill mo sa kuryente. Then, balancing. So, minsan, meron kayong multiple grills. Multiple grills, kaya lang kailangan balance yan. Depende sa design mo. Kuwari sa kwarto na to, 100 cube liter per second o QMS ang design mo. Tapos pagdating dun sa pagdating dun sa isang kwarto, 200 ang design mo dapat. Hindi mo na balance. Hindi mo na balance. O nung hindi mo na balance, wala na. Mali na yung dapat na airflow dun sa kwarto na yon is undersized. So kailangan mo siyang balansehin. Okay? Yan, let's continue. Yan, so of course, meron din fire and smoke control. May mga ducts tayo na ginagamit natin sa emergency purposes. Then of course, syempre sa mga kliyente, ang initial investment cost, which is it is a big factor lalo sa mga developer. Then, of course, we have the system operating costs. Siyempre, if you will not design your duct efficiently, then it will create more power or more electrical consumption sa motor mo. Okay, this is a sample of a duct system. So we have the main duct. We have the main duct. Okay, then we have the branch duct. Okay, nakita niyan, iba't ibang elbow yan. Okay, meron tayong rectangle duct, meron tayong circle duct, or sometimes meron tayong oval duct. Okay? So then we have elbows and we have transition. So pag lumiit, meron siyang transition. Okay? So ito yung mga iba't ibang klase ng ducting. So from circle, nag-transit siya ng rectangle. Pwede din yun. Kaya lang, there will be, of course, you need to consider the static loss. O ibig sabihin, o yung pressure loss. Ibig sabihin, ito ay dadagdag sa power ng motor mo kasi kailangan niyang isurpass o kailangan niyang higitan yung pressure para ma-deliver mo yung hangin sa pinakahuling terminal. Gets? Taas ang kamay, gets? Gets ba? Okay. Good. Okay, lower hands. Okay, sir. Paano naman how can we do the duct design? So, we can have different method. O baka manood sa exam nyo. We have the equal friction method. Equal friction method. We have the velocity method. We have the static regain. Is a mute. We have constant velocity. Okay? So, usually in equal friction method, we have a guide. Is a mute. We have a guide 0.6 to 0.8 Pascal per meter. So ano yung equal friction? Ibig sabihin, pare-pareho kayo ng pressure loss. Di-design mo siya ng pare-parehong pressure loss. So from either 0.6, usually ang supply, kunwari meron tayong sa mechanical ventilation system, meron tayong supply, ibig sabihin, ito yung bagong hangin, meron tayong exhaust. Ito yung lumang hangin. Bagong hangin, lumang hangin, old. Okay, so ito, sabihin natin, itong bagong hangin na to, tsaka lumang hangin, ito, along the duct, meron kang pressure loss. Siyempre, kada metro na biyahe niya, nababawasan ka ng energy. Or kasi dahil meron tayong na pressure loss sa duct. Kasi kung naalala nyo yung fluid meron tayong tinatawag na viscosity. Di ba? Sa fluid mechanics, meron tayong tinatawag na viscosity o kaya meron tayong tinatawag na fluid pressure loss along the pipe or pressure loss along the duct. Okay? So, yun. So, dito na yung yung fundamentals nyo, kaya kailangan nyo mag-aral talaga. Kasi, pag application na, dito nyo na maintindihan. Ba't nyo pinag-aaralan mga bagay-bagay sa school. So, makikita nyo dyan. So, kada biyahe ng hangin mula sa point A papunta sa point B, ay meron palang kawalan ng pressure. So, kada metro, meron kang 0.6. Usually, pag return o exhaust, nagdi-design tayo ng 0.6. Exhaust yan. Pag supply, nagdi-design tayo ng 0.8. Okay? Kasi medyo mabilis yung ano natin, velocity pag supply. So, kada metro, naglulus ka ng 0.8 Pascal. Pressure yan ha. Pascal, pressure. Okay? So, ito yon. So, equal friction, ano yan? Along the duct, equal siya. Okay? The next method is velocity method. Ito naman ay usually very common na ginagamit. Wari, nakita natin, pag main duct, usually 7 to 10. Okay? Pero sa mga large ano yan, sa mga large airflow. Okay? Pag branch duct, usually sa mga smaller airflow, 4 to 6 meter per second. Tapos sa neck, kasi 'di ba sa neck, wari may kita kayo sa ceiling niyo, 'di ba? Sa ceiling may makita kayong grill. Doon lumalabas yung hangin. Meron yang neck size. Neck tapos 'to yung duct nyo. Okay? Ito yung neck size nito, usually 3 to 4 meter per second. Yung diffuser nyo o yung grill, usually 2.5. Okay? Sabihin nyo na kung hindi nyo naintindihan, ha? Kung nakikita nyo sa mall, sa mga toilet, sa mga banyo, may makikita kayo butas sa ceiling. Doon lumalabas yung hangin o humihigop ng hangin. Di ba? Nakita nga pasok naman kayo sa mall, di ba? Tsaka sa ano. So, yon. So, the next is static regain. This is commonly used in industrial ventilation. This one requires a larger ductwork and not adequate for small airflow. So, ito yung mga tipo sa mga factor ito. Then, constant velocity, which is commonly sa kitchen exhaust tsaka sa toilet exhaust system. Okay, ayon sa 𝐒𝐴 is the code sa Europe o sa England. 𝐒𝐴, okay? Chartered Institute of British nakalimutan ko yung S and Engineering E. Okay? So ayon sa Guide A, air conditioning HVAC, heating, ventilation, air conditioning, ito ang recommended nilang velocity. So, kunwari sa sinihan, ano ang noise dapat? May noise din. Makikita nyo? May recommended noise. Engineer, paano mo maintindihan yung Spider-Man Away From Home kung maingay yung diffuser na dinesign mo, di ba? So, kailangan na makaka-apekto yan sa noise. Kunwari, 20-25, so ang main duct mo kailangan 4 lang. Branch duct mo 2.5 meter per second. Tapos, wait lang, tumatawag. Ayan. So, makikita mo, mababa ang duct. Sir, lahat na lang babaan natin duct. Hindi. Kasi pag mababa ang velocity ng duct, ibig sabihin malaki ang dimension. Lalaki ang dimension. Ang tanong sa'yo ng architect, paano pagkakasya yung duct sa ceiling ko, sa kisame ko? Bibigyan lang kita ng ng 300 mm na height. Pagkasya mo yung duct mo, wala pa pakialam sa'yo. Ganon sa mga architect. Siyempre, sabi ko, sige. Kaya lang, doon kayo papasok. Dapat, we are a good negotiators. Sabi ko, sige. Hindi nyo ako bigyan ng space, okay lang. Sasabihin ko sa kliyente, magiging maingay at saka makonsumo sa electricity ang mechanical ventilation na made-design ko. Di ba? Syempre, sasabihin ng kliyente, ikaw pa lang, bakit? Sabihin mo, gaganon pala eh. Ayoko ng ganon. So, ibigay mo yung size kay engineer. Close. Ganon yun. Ganon dapat tayo. We need to know your facts. You need to know your fundamentals so you can negotiate and win the battle. Diba? Yun. Siyempre, sa in construction, yan? It's a battle of knowledge and battle of strategy. Yon. So, meron tayong duct sizing chart. Ito, guide lang to. Kaya lang, you can calculate manually. Kaya tulad ng sinabi ko kanina is yung QAV. Di ba? Ito, guide lang to. This is duct sizing chart. Let's go fundamentals. Ito naman ay using Bernoulli's equation to get your static pressure. So, ito, masyado mahaba to. Hindi ko na di-discuss. Kaya lang, nakuha to from ASHRAE sa Bernoulli's equation. Na alam niyo yan sa fluid mechanics nyo. Third year. Third year yata yun. Third year ba fluid mechanics? Jan? Abel? Nasaan yun? Erica? Fluid mechanics, third year ba? Hello?
Yes, sir.
Yeah, yun. Galing ko, no? Tanda ko pa. Ayun. Okay. Let's go. Ayun. So, this is energy balance. Energy balance. So, hindi ko na siya masyadong di-discuss. Then, this is the system analysis of pressure drop. In summary, it is the summation of your pressure loss from your duct, from the grill, from the duct fittings, from any filters. Of course, syempre, sa kitchen exhaust system, meron kang electronic air static cleaner. Ito yung naglilinis ng hangin at ionize ng mantika. So, yun, may pressure loss yun. Ibig sabihin, may sagabal yun sa pagbuga ng hangin. So, mawawalan ka ng pressure, di ba? Kumari, pagbuga mo 100, dumaan ka ng electrostatic cleaner, minus 20, 80 na lang. Tapos ang haba ng ducting mo, 50 na lang. Tapos may damper ka pa, 20 na lang. Pagdating mo ng diffuser, magkano na lang, yung pressure ng hangin mo. So, yun yung kailangan mo i-calculate. Ito yon summary. Okay? Please unmute. Please mute. Mark, Joseph. Yan. Yan. So, ito naman yung pag-calculate ng hydraulic diameter. Okay. Renaline de Chavez. What is hydraulic diameter? Please read. Renaline de Chavez. Nasaan yun? Hello? Renaline de Chavez. Anyone who wants to read? Babasa lang oh. Hello?
Hello po.
Yeah. What's your name?
Michael Caldosa po.
Okay. From URS, Morong Rizal. Okay. What's hydraulic diameter?
Hydraulic diameter. A momentum analysis can relate average wall shear stress to pressure drop per unit length, turbulent flow in a passage of arbitrary shape but uniform longitudinal cross-sectional area. This analysis leads to the definition of hydraulic diameter.
Okay. So, in simple thoughts, itong hydraulic diameter is yung momentum analysis, okay, para masurpass yung stress. Kasi, di ba, kumari, sa isang, magdodrawing tayo, Dati hindi ko din naintindihan yan. Kaya lang guys, kung pag nasa field na kayo, may intindihan nyo pag nag-apply na kayo. So dumadaan ang hangin, meron yan, syempre, ang hangin, hindi naman, single line tayo single line na, hindi naman ganun hangin yan Diyos ko. may iba't ibang airflow yan sa loob ng sa loob ng ducting. So minsan nag-aano siya, tipong nagkaroon ng stress. Yung direction ng hangin is papunta dun sa ducting. Okay? Or sa pipe. So ito yung hydraulic diameter. So ito yung stress dun sa momentum shear stress sa loob ng duct. Okay? So, DH is equals to hydraulic diameter equals to 4 times the area in millimeter square times the perimeter of the cross section. Divided by perimeter of the cross section. Okay. Okay. Meron tayong, di ba, nakita mo sa duct fitting. Kanina, nakita niyo yung picture, meron tayong mga elbow, meron tayong kanina nakita natin yung ducting natin, meron tayong elbow, meron tayong damper, all these things ay duct fitting loss. So ito yung pagkuha ng duct fitting loss is equals to delta PT is equals to total pressure of loss of fitting is equals to CO, local loss of coefficient of fitting. Makikita nyo to minsan sa SMAC na. Ano yung SMAC na, sir? Yun yung sheet metal American fabrication of ducting. So ano yun sa Amerika yun, SMAC na. So makikita nyo to. Or tipong pwede nyo itanongin sa mga supplier ng duct fitting nyo. So times PV velocity pressure at the section of the fitting, Pascal. So makikita nyo dyan, ang duct fitting loss will be Pascal. Okay, so ito sample to ng SMAC na. Sheet Metal and Air Conditioning Contractors National Association. Okay, so sa elbow, round elbow, so ito yung kanyang coefficient. 0.71, 0.33, ito yung CO kanina nasabi. Wait lang. Ito yung kanina sinasabi, C. Okay, 0.71, 0.33, 0.22. So ito yon. So ito yung isa-substitute mo dun sa formula. Okay, so ito yung loss of coefficient. Pag kunwari meron tayong T, so makikita nyo ito, straight T duct. So ibig sabihin dito yung hangin, pag ganun siya. Pero sa last branch, pwede din T off, so dito yung hangin. So mas malaki ang pressure drop sa pinakadulo. So makikita nyo dyan yung loss coefficient. Okay? Hindi ko masyado itong di-discuss in detail kasi mapapahaba tayo. Ano lang to? Basic lang yan. May pinapakita ko sa inyo saan kukunin, paano kinakalculate, at ano ang fundamentals. Okay? Okay, grill sizing. O, baka lumabas to sa exam, makinig. So, makikita mo from the formula, Q is equals to area times velocity. Okay? Usually, yung ginagamit natin velocity is 2.5 meter per second. Tapos, so example, Q is equals to, example wari na determine mo through heat removal o kaya through air change o di ba? 100 liter per second ng airflow mo. Tapos, engineer, o anong size ng grill? So, ang gagawin natin, from the formula QAV is transpose area is equals to Q over V. So, airflow must be on CMH unit. So, from liter per second to CMH, divide mo ng 3.6. Di ba? So, magiging 0.1 o kaya from liter per second to cubic meter per second, ayan, makikita mo ng 0.1 cubic meter per second divided by 2.5 meter per second is equals to 0.04. Tapos, sir, 0.04. Paano yan, sir? Paano yan magiging 200 by 200? Kasi yung 0.04 mo, meter squared, square root mo is magiging 0.2 something. 0.2 something times, so times 100, magiging 200 by 200 mm. So yun yung size ng grill mo. Nakuha ba? Lalabas to sa exam, ha? Nakuha ba? Taas kamay. Nakuha? Taas kamay. Okay. Nakataas ang kamay nyo, pero pag tinatawag kayo, di sumasagot, ha? Okay. Please unmute. Please mute. Okay. Yes, sir. Grill size, okay na. Please mute. So, grill size, okay na tayo, sir. Ayan. O, louver sizing naman. Ano itong louver sizing? Ito yung makikita nyo sa mga mall, sa mga car park. Kung habang naglalakad kayo, may mga malaking grill, tapos minsan bubuga ng malakas na hangin sa kalsada. Diyan sa mga mall, may makita kayo malaking sa mga car park o kaya sa mga wall, sa labas, may kita kayo mga grill na louver. Yun. Parang grill, louver, may linya. So doon lumalabas o humihigop ng hangin. O ganito, from SIBSE, ito yung graph. So meron kayong airflow. So nakalculate mo na airflow. Engineer, may airflow ka na. Alam mo, tinuruan na kita paano mag-calculate. So may airflow ka, tapos meron kang aerial louver. Okay, sabihin natin 4 meter cube o 4,000 liters per second ang intake. Aban, laki niyan. Baka car park yan. So intake, so ang area mo is 2 meters square. So, convert mo na ng mm, square root mo, mas makukuha mo yung size. XL times width. Di ba? Square root, di ba? So, mari, exhaust naman siya. So, 4 meter cube dito. So, nasa 1.5 meters per second. Sir, wala kaming graph na ganyan. Mahirap lang kami. Hindi ganyan. Pero, may solusyon. May solusyon. Okay. So, kakalculate natin manually. Okay? Which is, usually, ito ginagamit ko. Louver sizing. From the formula, QAV, again, so area times velocity. So, velocity, usually, sa mga louver is 2.5 din. Kaya lang, meron tong twist. Meron siyang effective area given by the architect. Kailangan, alamin nyo sa mga architect. Architect, ano ang effective area mo sa louver mo? So pag sinabi na, okay, ang effective area ko is 50%. So ibig sabihin, di ba, kung makikita nyo sa louver, makikita nyo, ang daming abubot. Ano makikita ito? Kasi ayaw makita ng architect yung mga mechanical, may ducting natin, ayaw niya makita. So ang ginawa niya, kung makikita nyo, meron siyang pagganyan dito, tapos may pagganito dito, tapos may pagganyan pa siya. So ito lahat to nakakabawas ng effective opening. So usually, meron silang ibibigay ng manufacturer ng louver sa architect ano ang effective area na igagamitin natin sa kalkulasyon. So ang gagawin ay sabihin natin na-calculate natin yung from 100 liters per second, gagawin natin cubic meter per second, okay, divided by 2.5, which is this, then divided by 0.5. So, mas malaki siya kaysa sa grill. So, makita nyo, 0.08. Tapos, square root nyo, magiging 250 by 250. Length times width. Okay? So yun yung so ang dali lang, di ba? Yan na, nagdi-design na kayo, engineer. Oh, pera na yan. Sideline, pera na yan ba? Oh, kaya lang kailangan nyo magkaroon ng PME. Ayun. So, dapat aral kayo ng aral. Yan, PME. Okay. So, ito yun. So, nakuha ba yung oversizing? Taas kamay? Oversizing, lalabas sa exam. Dali lang exam natin. Multiple choice lang naman. Okay. Okay. Hands down. Okay. So, sir. Ano naman itong system effect, sir? So, meron na nakapag-calculate na tayo ng ducting, na tayo, calculate ng grill, calculate ng louver. So, alam na natin kung anong size ng fan. So, magse-select na tayo ng fan. Alam natin airflow. Na-compute na natin yung static pressure. Okay? Meron tayong system effect. So, sa system effect, fan system effect, ito yung pag magkaroon na kayo magse-select na kayo ng fan selection. So, meron tayong tinatawag na system effect o actual volume. Kasi ito yung design. So, makikita nyo. Ito yung design graph ng equipment. Kaya lang, base sa meron tayong actual duct system curve kasi meron tayong actual na efficiency. So, dito yung actual duct system curve. So, in difference ito, yung ng duty point, tatawag is duty point. In difference ng duty point, kumari, ang duty point mo is on this part, tapos pagdaba sa actual, ito ang duty point mo, magkakaroon tayo ng system effect. Ito ay after mo na ma-install ang fan, ha? So, usually, kino-consider natin sa design yung system effect para pagdating sa pag na-install natin is na consider na natin yun. Okay, usually system effect is 20%. So, usually pag nagdi-design tayo, nilalagyan natin ng 20%, not 20%, sorry. Sabihin natin mga 10% ang safety factor. Okay? Wala. Please mute. Okay, so natapos na natin system effect. So, makikita natin sa diagram na to yung system effect. Kasi nakikita nyo, pag centrifugal fan, ang hangin, hindi naman kagad inline na kayo, maglinya na kayo ba? So, ibig sabihin, dahil may centrifugal force, for example, sa fan, sa centrifugal fan, may centrifugal force. So, ang paglabas mo ng duct, ang airflow pattern mo, ganito muna. Hanggang sa pagdating dito sa part na to, ito yung tipong lahat ng spasyo ng ducting mo is nakonsumo na nila. Okay? Kasi ang hangin, dahil ang bilis niyan, dito, pag ganyan, syempre dito muna sila mag-ipon-ipon. Tapos habang patagal ng pahaba, ikukonsumo niya na yung buong space ng duct. Yun yung system effect. Ganon din naman sa exhaust. Nakikita nyo dito. So dito, maliit yung kanyang funnel. So magkakaroon siya ng system effect. Okay. So, fan selection. Usually, meron tayong airflow, static pressure, tapos meron tayong fan curve. Okay? So, ito yung circle, ito yung duty point nyo. Okay? Ito yung normal operating range ng fan curve ng sinelect mong fan. Okay. Noise control. Sir, bakit kailangan natin ng noise control? Kasi fan can generate sound, octave bands. High airflow or high static pressure loss can generate high noise levels. Okay? Tapos, noise control can affect the health and activity of a person. Okay? So, itong recommended sound levels ayon sa Singapore Standard SS553. Tapos, dito naman sa OSHA's, the Occupational Safety Hazard Association, ito naman ang kailangan noise exposures. Okay? So, anong mga iba't ibang klase ng silencer? Yung mga silencer, ito yung nag-absorb or nag-attenuate ng noise from the fan. Okay? This mute. So, anong kailangan mo gawin? So, you need to determine the noise criteria of the space. Okay? Anong na-discuss natin kanina? Ano yung noise criteria? Ano mga recommended noise level? Sa SIBSE kanina, pinakita ko sa inyo. Tapos, select the fan. So, na-select mo yung fan to determine the sound octave levels. So, na-select mo yung fan mo. From yung fan selection, makikita mo ano ang sound octave levels ng sinelect mong fan. Tapos, determine how many decibels you need to decrease. Depende sa noise criteria. Kung ang fan mo ay nagge-generate ng 60 decibels, please mute. Okay, so kung ang fan mo nagde-decimate ng 60 decibels, tapos ang required mo, ang noise criteria na sinabi sa'yo ng SIBSE, dapat 40 ka lang. So, ang kailangan mo mabawas na decibels is 20. Yun, doon ka magse-select ng silencer. Okay? So, points to consider. Oh, ito yung ginawa. Ito, guys, no joke po ha. Real talk lang ha. Ito yung dinesign kong MRT depot sa Singapore. Nag-Navis work ako. Ito yung 3D kami dito eh. So, ito ako, ganyan kalaki ang silencer ko. So, sobrang laki ng airflow. Ganyan kalaki silencer ko. Ito ako, 2 meter yan. Oh. Tapos magkapatong pa yan. Yun. Kaya no joke talaga mga malalaking fan sa industrial. Talagang di mo kahit ilang tao pang bumuhat yan, talagang makina talaga bubuhat yan. Okay? So, meron kang pressure. Tapos ito mga to, malaki din ang pressure drop na nakukuha. Kasi ina-attenuate nila kasi ang airflow mo eh. Ina-attenuate nila yung noise. Kaya malaki ang pressure drop na nagkakaroon ang result ng pressure drop. Tapos, so, ang gagawin nyo is acoustic calculation. So, usually, meron tayong mga software dyan na nagkakalculate ng acoustic calculation. So, nakita nyo, ano ang octave levels na ito yung sinelect kong fan. Makinig. So, ito yung sinelect kong fan. Tapos, ito yung octave level. Tapos, ilan ang kailangan kong decibel. So ito yung tapos may makikita ka din na ano ang position ng grills mo, gaano kalaki ang room, kinakalculate talaga nila yan. Tapos ito yung bibigay nilang recommendation silencer sa ganitong noise criteria na fan na gusto mong i-select. Ay gusto mong ingay sa loob ng kwarto. Okay? Ano yan? Ito ay sa underground MRT depot. Yan, selection ko na yan. So, okay. Okay. Mabilisan lang. Life safety ventilation. So, makikita naman natin sa na paano ko sa inyo kanina, meron tayong ang mechanical ventilation ay ginagamit din natin sa life safety. Okay? Ginagamit natin sa life safety yan. So, saan ginagamit ang mechanical ventilation? Sa staircase pressurization, tsaka sa smoke purging routing. Tapos, meron pa sa car park, smoke purging, and engineered smoke extraction. Okay? Pero, meron din tayong pwedeng gawing natural engineered smoke ventilation. Pero ito ay nagagamit lang pag meron kang simulation software or CFD, Computational Fluid Dynamics Software. Okay? So, saan ginagamit ang purpose of life safety ventilation? So, at the outset of the design, it should be clear why a smoke control system is required. So, some examples are to improve visibility on a long distance escape route. So, kasi pag nasusunog ang isang building, tapos malayo pa yung fire escape, para makatakbo ka papunta sa fire escape, kailangan mo ng ventilasyon. Kasi pag di mo nakikita dahil sa usok, doon ka na mamamatay sa suffocation. Okay? To improve tenability during escape from a large enclosure. So, then to improve visibility and tenability for firefighting access. Kasi kailangan maging visible din para sa mga bombero para alam nila kung saan nanggagaling ang sunog. Okay? Then, to limit the smoke spread during phase evacuation. Then, to limit smoke damage to equipment furnishings. Kasi kailangan i-asset protection din natin. Kasi pag yung smoke, pag kumari nadaanan na nasunugan kayo, diba? Yung mga appliances nyo nangingitim o kaya mga pader nangingitim, diba? Kaya yun. Kung nabawasan yung smoke, mababawasan yung limit ng pangingitim ng mga pader nyo o kaya ng mga furnitures nyo, mga gamit nyo, diba? So, anong design approach? So, kailangan malaman mo ang fire size. Tapos, geometry of space. Okay? Height of space. Tapos, ano ang smoke layer height? Ano yung smoke layer height? Ibig sabihin, doon yung madedetermine kung gaano kataas ang magiging layer ng usok. Dahil, kunwari, nagsunog kayo ng isang band, isang tatlong rim ng bond paper, nagsunog kayo. Di ba? So, base sa tatlong rim ng bond paper, ano ang layer ng height? So, ganun din. That's analogy. Let's say, nasunog ang isang casino table, nasunog ang isang casino machine. So, ano magiging layer ng smoke mo? So, yun. So, i-consider din natin kung ang space is sprinkler or not sprinkler. Kasi makaka-apekto yan sa volume ng smoke. Tapos, of course, syempre, smoke clearance height. Ano ang clearance na kailangan mo para makatakbo ang mga tao? Then, syempre, yung temperature ng sprinkler ng na bago pumutok. Usually, 68 degrees Celsius yun. Okay? So, yun. So, nasa second part tayo ng smoke management system. So, yun. So, ito, mabilisan lang. Course outline, importance of smoke management. Ito ay very similar pero iba lang ang methodology ng pag-calculate. Kasi ang different of yung calculation method niya is based sa gaano kadami, ano ang behavior ng fire. Okay? So, types of fan to be used, design points you need to remember. So, what is smoke management? Okay? Pakibasa, Danica Albao.
Smoke management, a smoke control method that utilizes natural or mechanical system to maintain a tenable environment and the means of egress from a large volume space, or to control and reduce the migration of smoke between the fire area and communicating spaces.
Okay, in short guys, tayo nga engineer, tayo magmamanage kung saan natin padadaanin ng smoke, gaano ka siya kalaki, gaano siya ka-thick layer, and gaano siya gaano siya kadami. Okay? At paano mo siya, at saan siya dadaan? Paano siyang padadaanin? Yun ang smoke management system. Napakasimple. Okay? Which is, syempre, yan, importance ng smoke, syempre, is life safety. Diba? Westy Lorenzo. Pakibasa.
Sir, so life safety according to NFPA 92, the containment of smoke, the zone of the region, the establishment and maintenance of pressure difference across smoke zone and boundaries. Next is the management of smoke within a large volume space and any separated spaces that communicate with a large volume space.
8. Very naman yan. Understandable. Design objective. Ayan. Pakibasa 𝐏𝐡𝐢𝐥𝐢𝐃 Eva. 𝐏𝐡𝐢𝐥𝐢𝐃. Ano si 𝐏𝐡𝐢𝐥𝐢𝐃? Almira Frey Fronda. URSM. Almira. Babasahin lang oh. Asan yun? Kasi nawala si Almira. Si Daniela Peñalosa. ADU. Adamson. Adamson ba to? Daniela Peñalosa. Adamson. ADU. Adamson ba to? Adamson yan. Babasahin lang. Ayaw nyo? Sinong gusto mong basa?
Ano lang, sir?
Okay. Go, go, go. Sino to?
Ito po, ako po.
Sino yan?
Mark Efren Rojas from PUP Margondon.
Yan. Go, go, go.
Here's the design objective. Containing the smoke to the zone of fire origin. Maintaining a tenable environment within exit stairwells for the time necessary to allow occupants to exit the building. Maintaining a tenable environment within all exit access and smoke refuge area access paths for the time necessary to allow occupants to reach an exit or smoke refuge area. And lastly, maintaining the smoke layer interface to a predetermined elevation in large volume spaces.
Oh, napaka self-explanation yan, no? Ano lang yan, guys, parang tipong paano mo nyo mamamanage yung smoke para makalabas sa mga tao. Diba? So, kailangan ilayo yung smoke sa mga staircase or refuge areas, tapos panatiliin yung thickness ng smoke para nakita ng tao yung exit at panatiliin yung smoke layer para hindi sila masuffocate, mamatay sa usok. Okay? Okay, types of fire. Lalaki. Okay, babae. Cristel Lisa Del Rosario, DMMSU. Oh, DMMSU to ha. Baka di pa sumagot to. DMMSU to. Sino to? Cristel Lisa.
Hello, sir.
Basa.
Types of fire. Fuel-limited fire. A fire that has a heat release rate that is controlled by the material burning. Steady fire. A fire that has a constant heat release rate. T-squared fire. A fire that has a heat release rate that grows proportionally to the square of time from ignition. Unsteady fire. A fire that has a heat release rate that varies with respect to time. And last, ventilation limited fire. A fire where every object in the fire compartment is fully involved in fire and the heat release rate depends on the airflow through openings to the fire compartment.
Okay. Very naman yun. Self-explanatory. So, iba't iba ang klase ng fire, guys. Depende yan kung ano ang source. What is the source of your the source of the ignition? So, ano bang materials niyan? So, pwedeng gasolina, magiging T-squared. O pwede magiging battery room. Battery room. Sir, saan na ginagamit ng battery room? Ang battery room ginagamit yan sa mga MRT. Okay? Kasi, okay sa mga automotive industries. Nalagyan ng mga baterya. So, itong mga to, pag yan, nag-ignite, napaka explosive. So, T-squared yun. So, may iba't ibang requirements yan para ma-manage yung smoke. Okay? Okay. Ano tayo? Tawag. Basa. Gatdula. James Marvin. PUP AC. Gatdula. Wala. O si Mary Irish Lakinalaw. Ano to? Bulacan State University. Mary Irish Lakinalaw. Uy, babasahin lang ba? Sinong gusto mong basa?
Ako na lang, sir, para mabilis, sir.
Sure.
From Adamson po, J. Ward.
Yan.
Definition of smoke. Smoke, the airborne solid and liquid particulates and gases involved when a material undergoes pyrolysis or combustion, together with the quality of the air that is entertained or otherwise mixed into the mass. Thank you po.
Okay. To, tandaan nyo, baka lumabas sa exam to Okay, smoke. So nakikita nyo gaano ka-deadly ang smoke. Kasi, guys, depende yan sa sinunog. Ano magiging combustion reaction yan? Okay? Kung hindi nyo na-maintain, engineer, ang smoke, at hindi, mamamatay yan in minutes ang tao pag nalanghap. Kasi, kunwari, nalanghap niya is deadly pa yung chemical reaction. Tapos may comorbidity pa siya. May sakit siya sa lungs. O sigurado patay yun. Diba? Kaya, may mga tao sa resorts world, di ba, namatay dahil sa suffocation, dahil nga, hindi sila nakahinga, dahil hindi nga sila, kasi ang smoke, ang fire, nagko-consume ng oxygen. Ang fuel ng fire is oxygen. So, pag nawala ng oxygen, ayun, mamamatay ang tao. O yun. Aba, meron tayong basta Ariel. Sir Ariel, nanonood, Okay. So, design basis. Sinong gusto mong basa? Mabilis.
Ako na lang.
Sure. Sino to?
Ako na lang po.
Ariel.
Puting.
Pwede ba
Sir
ako, sir?
Ariel, oh. Sige, sir. Alas tek, magaling ka pa sa akin eh.
Sige. Design basis. The design basis for smoke management within a given large volume space and any unseparated space shall include the determination of the following parameters. First, the design basis requires used to calculate smoke production. Example, type, location, and quantity of fuel for each design basis fire. Extent of coverage and reliability of automatic suppression, and extent and type of ventilation. Second, height, cross-sectional area, and plant area of the large volume space to be protected. Then, third, height, cross-sectional area, and plant area of each unseparated space that communicates within the large volume space. Fourth, type and location of occupancies within and communicating with the large volume space. Fifth, barriers, if any, that separate the communicating space from the large volume space. Six, ingress roads from the large volume space and any communicating space. And last but not the least, any areas of refuge. Salamat, sir.
Yan, salamat sa pinaka-idol ko. From Japan. Ayan, so, guys, alam mo yun? So, it depends on your, actually, it depends on the architectural layout. And then, you need to study how will you manage the smoke, the direction of the smoke. Saan ang outlet mo, saan ang fresh air mo, saan ang pupunta, saan ang exhaust grill mo. Lahat ng ito, kailangan mo i-consider para may direct mo ang smoke at makontrol mo yung kapal ng usok para makalabas ng tao. That's the design basis in a summary form. Okay? Tapos, syempre may barriers ka dyan. Ano yung mga barriers, sir? Ito yung mga smoke barriers. Ito makikita yung sa mall. Minsan, mga high, ewan ko sa Pinas na, sa Ayala Malls, may bumababa yan na smoke barrier pag kumari mayroon siyang sunog. May bumababa na smoke barrier. Ano yung smoke barrier, sir? Yun yung magsasangga ng usok. Kumari, para hindi siya makapasok doon at may direct sa ibang lugar. Yun ang smoke barrier. Okay? Diba? So, let's continue. Yan, smoke containment system. Design approach, we have staircase pressurization. We have zone smoke control and elevator pressurization, vestibule pressurization, and smoke refuge. So, same concept, different formulas lang yung mga sir. Okay? So, ito, na-discuss natin to. So, by air change din, mga iba. So, kailangan ang mga design parameters, fire size. Yung fire size, guys, usually, nakukuha mo to sa, sa mga fire consultant kasi minsan sinasimulate nila yan yung fire size calculation na yan. Okay? So usually ito ginagamit natin to sa mga given to from the fire consultant sa project team. Project consultant. So geometry of the space, height of the space, smoke layer. So na-discuss natin to, temperature. So isa sa mga formula is height of indication with no smoke exhaust operating. So makuha mo to sa NFPA NFPA 95. Okay? So ASHRAE 95 lang. So steady design, ito yung formula. So ito yung sinasabi ko, guys, common kinds of plumes. So may kita nyo yung plume, ibig sabihin yung paggawa ng usok. Meron tayong asymmetric plumes. Ito yung wala siyang sagabal. Talagang height ng smoke lang. Tapos mayroon tayong balcony spill plumes. Wala ang source ng fire mo nasa balcony. Paki-mute. Yun ito mute. Paki-mute po. And then we have window plumes. Usually ito sa mga condo. o kaya sa mga retail shops, ganun. Ito, window plumes. So, iba't ibang kinds of plumes yan. So, pag assessment rate, ito ang yung NFPA 92, ito yung formula. Pag balcony, ito naman ang formula. So, kailangan nyo ng NFPA 92. Then, pag window sphere plume, ito naman ang formula. So, but same, different constant lang yan, different exponential, yung nakikita nyo, 5/3, mga ano to, mga tipong na-derive to from simulation. So, ano to, design para sa mga ganon scenario. Okay? So, ano kailangan natin gawin dyan is gamitin na fan. Dapat yung motor nasa labas para hindi masunog. Okay? Yan ang pinaka-importante kasi minsan may mga engineer sa basta ayoko na mag-name. Iba ang ginagamit. Minsan ginagamit na AHU, air handling unit para makatipid. Tapos higupin yung air. Tapos yung usok, yung usok mainit yan eh. Tapos pag yung motor nasa loob, nadaanan ng mainit na bagay, malulusaw yung mga kable. Pag nalusaw yung kable, wala na. Hindi nagagana yung fan. So, 'di ba? So kailangan tamang fan, bifurcated fan or smoke fan ang gamitin. So nakikita niyo to, meron tayong smoke damper, meron tayong smoke curtain, at smoke barrier na minamanage natin para ma-manage yung mga usok kung saan dadaan. Tapos, meron tayo din siyang mga smoke sensor para distinguish mo saan yung sunog. Okay? At gaano ka na kalaki. Depende sa area. Kasi magre-reflect yan sa smoke control panel. Okay? So, yon. Bago exam, may tanong ba? Bago tayo mag-example ng design. May tanong ba? Ano? Ang tanong?
Sir, may tanong po si Emmanuel. Mas safe po ba mas mataas yung air change pag may smoke?
Actually, hindi siya by air change eh. Kaya lang mas mataas siya definitely. Kaya lang hindi siya by air change. Ano ba siya? Kasi may mga ibang lumang calculation, lumang methodology na ginagamit nila. Minsan kasi ginagamit nila 50 air change. Kaya lang hindi na 'yun dapat angkop sa sa mga bagong methodology ng design ngayon. Dapat kina-calculate na talaga yung mass flow rate para sa smoke. Okay? Mga iba kasi ginagamit nila 50 air change lang, ganun. So 20 air change which is very outdated na. Kaya yun. Outdated na siya. Okay? Any more question? Bago tayo mag-sample ng calculation. Magana tayo? May question bago siguro 5-minute break? Toilet break?
Alright, sir.
May question ba?
May tanong po si Ma'am Jessa po, nagtataas po siya na
Yes. Go. Sorry, di ako nakakapagbasa.
Ay, never mind po. Nag-raise po kasi siya ng kamay kanina.
Ano nga? May tanong ba?
Sir, nag-raise po siya. Ayun po, may isa po si Junsar.
Yeah.
Nag-raise po siya ng kamay. You can kindly open your microphone po.
Hello sir, good afternoon po.
Hi sir.
Sir, paano pag hindi na-balance po? Pagdating ng testing and commissioning, ano po yung suggestion na strategy para mahanap yung kung saan yung example may
Actually, sa totoo lang, sir, malamang may, ano ka na, sir, di ka na student. Ano ka na? Ano ka na ba, sir? Nasa working ka na ba, sir?
medyo sir.
Ayan. Hindi, kasi sir, actually sa totoo lang, kailangan, pag na-install na, kailangan mo talaga balansehin. Alam mo yun, you need to go back, anong designed airflow. Alam mo yun, tapos, kailangan mong sukatin ulit by barometric and para matignan mo kung anong airflow talaga na lumalabas sa terminals mo. Kasi kung hindi, wala, talagang magkakaroon ka ng hotspot dyan. O kaya condensation kung mas grabe.
Sige sir, thank you po.
Ayan. There's no way talaga. Kailangan mong balansin yan, engineer. Unless ang gagawin mo, ayaw mong balansin, is mag-supply ka ng another unit, which is more expensive para sa kliyente. Another unit ka, panibagong unit. Supplementary on what is the base. What is base provision provided. Diba? Okay? Okay? Any more question?
Sir, meron pa po kay Tio Philo. So, sir, kayo po ba mag-i-install ng FDAS para sa smoke?
Ulit? Anong tanong?
Sir, kayo po ba mag-i-install ng FDAS para sa smoke?
Kami ba ang papasa ng FDAS sa smoke?
Yeah.
Magpapasa FDAS is a requirement eh. Usually kung sino nag-design ng smoke, siya magpapasa ng FDAS.
Alright, sir. So, meron po tayo nag-raise po ng hand, si Don Sevilla. So, kindly open your microphone po.
Ano yan?
Yes, sir, good afternoon.
Okay. Yes, good afternoon.
Sir, with regards to duct sizing, tulad ng sinabi nyo kanina, if ever limited lang yung space na binigay ni architect, how can we resize our duct size para makapasok sa
There are several ways There are several ways which for example, you need to calculate the pressure loss again. And then you need to see whether there is still some ample allowance. Then if from there you can kumare ang na-design is 4 meter per second. So pwede kang umangat ng 5 meter to 6 meter. Alam mo yun, which is I think it's ano ba yung space? Anong space? Anong space? Office?
If ever, halimbawa ganun, sir. Office area.
Office kasi, office, go, I think until 8 meter per second is, anong height ng building? If let's say nasa 4 meters, 8 meters, okay. But, 3 meters lang yan. Katulad nagtitipid mga may-ari, 3 meters lang ang height ng ceiling. Alam mo yun? So, I suggest mga 6 lang. Kasi, gusto mong office, alam mo yun, ayaw natin umungol yung ducting ba? Di ba? Kasi, pag umungol yan, wala na, that's it. Alam mo yun, hindi mo na magko-compartment ka na lang para ma-contain mo yung ingay, di ba? Which is a big coordination issue and also a big delay. So yun. The thing is that you can do is divert, yung tipong make it flatten but not so flat. The aspect ratio that I recommend is not more than 1:5. 1:4 is my ideal. 1:5 is is okay. But other than 1:5, ano mo yung 1:5 aspect ratio? 1:5 aspect ratio. Okay. Kunwari, ano ba? I-discuss ko kunwari, ang 600 by 200. Ano aspect ratio nun? 1:3. Diba? 200, 1, 600, 3. Gets mo?
Yes, sir.
Diba? Kasi 200 times 3, 600, diba?
Yes, sir.
So 1:3. So kung ang duct mo, hindi dapat more than 1:5. Kung ang height ng duct mo is 200, so hindi ka dapat lalampas ng 1,000. Gets mo, engineer?
Yes, sir. Okay.
Okay? So yun. So huwag kang dapat lalampas sa aspect ratio ng 1:5. Kung yun ang suggestion ko. Kung hindi kaya nun, pwede kang mag multi-branch. Multi-branch. Ano mo multi-branch?
Magdadagdag tayo ng branch, sir.
Yes, correct. Multi-branch. Then, saka mo, pag lumit ng airflow, mamamanage mo yung size. Gets?
Noted, sir. Thank you.
Okay, natulungan ba kita? Yes or no?
Yes, sir. Yes, sir.
Okay, good.
Thank
Okay,
you.
next.
Sir, we have a raise of hand kay
Yeah.
Engineer Ariel po.
Ayan, sir. O, baka may suggestion pala.
Hindi, sir, yung nagtanong sa'yo nung una kanina, yung hindi niya mabalance yung sistema.
Ayan, magaling. Si Sir Ariel, ano yan? Sa contractor yan. Magaling yan. Ano yan, sir?
I-check niyan yung fan. Bago nila i-balance kasi, baka ang ginagawa nila, nag-umpisa sila sa grill. Pwede naman yun. Kaso nga lang, ang suggestion ko, kunin nila yung central static pressure dun sa main duct. Tsaka yung duct traverse muna. Bago sila mag-balance. Kasi yung drill kasi may correction factor yan eh. Pag yung lahat ng drills may correction factor. Ngayon, pag ang ginagamit mong correction factor is 1, hindi mo talaga mababalance yung system. Mag-umpisa sila sa duct traverse. Kung alam nila ang ibig kong sabihin ng duct traverse, gagamit sila ng pitot tube para makuha yung duct traverse. Yun lang sa akin, sir, baka kung may
baka makatulong, no?
Kung may question yung kwan pa, para may pamaliwanag kung mabuti, kasi makakapaliwanagan, yan niya
PM.
ako.
Yes.
PM niya ako.
PM's the key.
Yeah. Kasi ako kasi nagpo-commissioning din dito sa sistema ko eh.
Sa Japan.
Hindi, nandito ako sa China, bro.
China. Okay. Yung pala, China. China ka na pala ngayon, ha? Okay. Okay, naintindihan ba? Naintindihan? May question pa? Bago tayo calculate.
Yes, sir. Meron pa po kay
Ano?
Engineer J-Mar po. Ang tanong po is, ano po, sir, yung ginagamit na sa maliban sa CFD para sa computation ng airflow?
Hindi naman tayo gumagamit ng CFD sa computation ng airflow. Doesn't mean sa computation ng airflow para sa natural smoke control? Anong airflow kino-compute niya? Natural engineered smoke control? Hello? Mute? Sino nag-mute? Paki-mute.
Paki-mute po ng microphone. Excuse me. Sa participant po namin, please mute your microphone po.
Okay. Na-mute ko na. Okay, ano yun ulit?
Yun po. Yun po yung tanong po ni
hindi klaro yung tanong kasi airflow from the natural smoke control, engineered smoke control. Kasi kung natural engineered smoke control, ano yun, talagang CFD talaga dapat yun. Hindi kaya ng kasi you will simulate the pattern of air para i-analogy mo sa behavior ng smoke. Depende sa architectural layout mo. Gets? May question pa ba?
Meron pa po, sir.
Ano?
Kay Dennis po. Madalas din po ba na di-design yung branch duct na sa above and under the main duct yung connection pag sa po kasi nasa side kalimitahan yung connection ng branch duct sa main duct.
Yes, as long as you have a splitter. You have a splitter damper. You have a parang tipong guide vane para yung mag-guide yung ano, yung air papunta sa duct mo. Okay? Air is fluid, guys. Alam mo yun? Basta meron siyang guide vane, papasok ng duct yung ano, yung air kahit sa baba. I've done that in my project. And next question.
Yeah, sir, we have from Jittifer. So, sir, architect at engineer ang nagpa-facilitate ng design. Pero pag sa scenario po, sir, na magkaiba sila ng idea or design ng ventilation sa isang project, sino po, sir, dapat masunod sa kanila? Salamat po, sir.
Very good question. It's the art of debate. It's the art of reasoning. You need to reason out and then fight for your design. Actually, for me, alam mo yun, for me, I will get the point of the architect, but if his reasoning will jeopardize the best interest of the client, then I will reason out. Okay? Maliwanag ba? Nasagot ba yung tanong? Okay.
So we have from Oswald po. So sir, how do you start a career sa mechanical ventilation from a fresh grad standpoint? May trainings po ba na pwedeng i-take?
Walang training. Alam mo yun, sa totoo lang, you have to train yourself. That's the best. And then, the best scenario is your attitude. You need to ask question. Alam mo yun, if you don't ask questions, mayayain ang tao. Then you need to have a mentor. Tipong ganun, para yun. I've started mechanical ventilation, not only mechanical ventilation. I started air conditioning air conditioning work experience way back 2007. I was from manufacturing industry. Then I got bored, so I go to air conditioning, which is a different fighting plan. Alam mo yun, so I then nagano lang ako, naging trainee ulit ako, bumaba sweldo ko, pero in the long run it benefits me. Doon ako naging PME. Then my first working design is Sabah kagad. Dinesign namin ng Burj Khalifa. Ano mo yun? Sa Dubai. Ano mo yun? Walang ano mo yun? It will no pain no gain eh. Ano mo yun? Di kami umuwi ng 6 walang uwian yun lagi. So kailangan mo na talagang matuto na mabilis and huwag ka mahiyang magtanong. Okay? Sagot ba yung tanong? Hello?
Yan po, sir. Wala pa naman pong response. Pero
Okay.
meron po ulit tayo kay Jmar. Kaya din ba, sir, yung nagko-compute ng area of airwell?
Airwell, no. Airwell is architect, guys. Alam mo yun? It's a natural ventilation eh. Airwell usually is natural ventilated system. So you will compute by simulation because you will average out the direction and the speed of air on the area. In different areas, different air speed air movement. Mare, let's say Bulacan, air movement is different when you go to Pasig, which madaming building. So, ang air movement ng Pasig is mabagal kasi panay madaming building. So, depende yun, guys. Sa Bulacan, malawak ang so mas walang hindrances, mas mabilis ang hangin. So, ano mo yun? Airwell, ibang ibang field. Kasi airwell is kaya nga airwell it is the source of your natural ventilation for your for the space where the air comes from. Any more question?
Yung po, sir.
Okay,
Ito po. So, sir, habol po.
Okay.
May
Last na yan para tayo makapag-example tayo
Tayo po. So, sir, may habol po. Ilan po ang average salary po ng isang engineer na nagde-design po ng mga air ventilation tulad po sa inyo? Salamat po.
Depende sa lugar. Si Ariel? Tangin lang yan. Sorry. Oy, huwag kang ganyan. Fake news ka. Hindi, guys, you need to market yourself. And then your salary is based on your performance. Sa totoo lang. So, if people knows you well, minsan pinapirate ka. Tipong minsan nga minamakahan ka ng kung magkano sa ulo mo. Sige, lumipat ka na sa amin. Ito, bigyan kita na ito. Ganyan, parang bagay. Ginawa kang bagay. Bigyan kita ng ganitong sweldo. Ganyan. So, you need to market yourself. You need to be knowledgeable enough so you can demand. Kasi kung hindi ka, kung kaya lang gusto mong average cut, yun, I started in Singapore, na real talk, 60,000. Yun? 70,000 pa lang. 70 to 80,000 at year 2007. Okay, so you need to market yourself. You need to study more. Then you can then use some skills. Yun, which is papakita ko ngayon. Ayan, last question na yan which yung papakita ko ngayon. Yun. Siguro 5 minutes break, toilet break.
Sige po, sir. So,
5 minutes toilet break para quick example lang.
Sige po, sir. Para sa break po, muna tayo, mag-icebreaker muna po tayo.
Okay.
Just to, lighten up the mood. Okay, so students, sadya pa ba kayo? Oh, wait. Hindi pa po nag-stop ng share si sir. So, we can't proceed.
Wait lang.
Ay, so.
May nag-deliver po. Wait lang.
Yeah.
Stop share. Okay.
Yes po, sir. Thank you po. Okay, so yun guys. So, nandiyan pa ba kayo? Can you give me any reaction if you're there? Just any thumbs up or raise hand or anything? Right. Okay. So, marami pang gising. Good. That's a good sign. So, magkakaroon muna tayo ng icebreaker. Okay? So, you're still there? Still there? Can you give me a hi? Can you type in? Can you type in the comment section? Can you type? All right. Okay. Hi. Present. Okay. All right. So, let's proceed to the icebreakers, shall we? Okay. Ano nga ba to? So, ang icebreaker natin is guess the optical illusion. So, pero meron tayong may twist tayo sa optical illusion na to, okay? So, hindi ko sasabihin kung how you would answer this optical illusion. So, you have to figure out kung paano mo mahahanap yung answer. Okay? So, you can twist your phone, you can do whatever you like, or pwede mong baliktarin, whatsoever. You know how optical illusion works, right? So, this is a mixed optical illusion, guys, ha? So, hindi siya magsistick sa isang way of looking for the answer. Okay? Ready na ba kayo? Ready na? Alright. So, okay. This is the first. Ano yung una nyong nakita? Type in ko rin una nyong nakita.
Love.
Okay. Aba. Note. Bale. Okay. Love. Hate. Oh, ang madami nakita ng hate. Blue. It's nice. Note. Hate, love. Okay, so yung answer natin dyan is either hate or love. Okay? So yan, hate or love tayo. So alam nyo na yung mga una nyo nakita ha. Hindi, joke lang. Ano lang yan guys? Pang pagising lang yan. Okay? Easy round yan. Easy round. Okay? Alright, so let's move on to our next. Okay, ano to? What do you see here? What do you see here? What's this? Pabilisan to guys ha. Okay, so meron na agad. Okay. What's this? Noella May. So tama. So what want something like this? Okay, so the answer is want something like this. All right, so let's head on to our next obstacle. Okay, here we go. What's this? Go guys, so find a way to actually read this. Okay, so meron na from Noel Isaiah. So the answer is hindi po iyo. Send garlic bread. Yes. So the answer is send garlic bread. Okay, how about this one? Paano pa yung mga naka-laptop? I can only imagine. Trust me, I tried. Okay, ano to guys? EO plus. Siguro nga. Okay, ano to? Alright, so may nakasagot na. Si Jericho. So, you're precious and I love you. Okay. So nice. How about this one? So kung gusto nyo gamitin yun sa crush nyo, go ahead. Diba? It's a smart way. Lugi laptop, yeah. Totoo yun. But don't worry, may advantage mamaya mga naka-lobby. Okay, how about this one? Ay, hindi po to barcode. Okay. Hindi po rip laptop. Okay, so what's this? Okay. May nakasagot na. So the answer is you're doing great and I'm glad you exist. Now, isn't that true? Diba? So nakaka-inspire mga ano natin yan. Okay, so next. Ano lang to guys ha? Mga easy lang to. Kasi alam ko naman kayang-kaya nito eh. Oo naman. Okay, so yun. Yon. So meron na. The answer is by Marco. Yeah. Eureka. So the answer is Eureka. Sorry if any of you can hear the electric fan. It's kind of hot. Okay, so meron ulit. From Marco again. Gusto mo mag-type pa? Okay, so the answer is bad eyes. So ito yung mga nagsasabi kanina ng EO. Hindi, joke lang. But I know the struggle. Yon. Okay, how about this? What's this? Yon. Meron na agad. So, kay John Paul. So, ang answer is, oh, hi, Mark. So, kung sino ka man, Mark, hi. Okay. So, for our next.
You know, the more you look, the less you take.
Okay, so sino yon? Hello po. Yes, that's right. So, the more you look, the less you see. Guys, this is not to challenge you. This is like
hide and seek.
Yan, hide and seek. So yun guys, hindi to guys hindi to pang challenge na yun. Kasi lang to, for like a wake up call, like a friendly game lang, di ba? So yun, so hide and seek. So I think that would be the last one. Yun. So for you guys, gusto ko kayo itanong sa mga optical illusions na pinakita kanina. Kayo, what are your favorite optical illusions? Gusto ko na marinig yung side nyo. So can you drop in the comment section? Mga gusto nyo mga optical illusions. Like, yung una nyo palang makikita, like, na kayo? Like, wow na lang. Okay, yung makita siyang may iba po. Well, nga naman. Pero hindi optical illusion. Okay, so yun. Yung kala ko sa bakit ang daming broken ngayon? Anong meron? Guys, it's still Feb. It's still Feb. Gunin mo lang siya. TikTok. Okay, so maraming natatawa ha. Ito ata yung talaga. Ito ata talaga yung epekto ng love and hate sa pinakauna. Optical illusion na akala mo 3 grado mo, 5 pala. Napakalala naman ng optical illusion na yon. Okay.
I see na.
Okay po. So, thank you students for participating in our icebreaker. Now I'll give the virtual floor again to Engineer Klaus.
Okay. Okay guys. Gusto ko kasi kayo matuto talaga. Pwede na mas maging magaling pa kayo sa amin. Kasi pag mas magaling kayo sa amin, at least may pag-asa ng bansa. Anyways, yan. So, mag-practice tayo. Paano ba mag-design, sir? So, this is Revit. Okay? This is a powerful tool. Makikita nyo gaano siya ka-powerful. So, ngayon, gawin natin to. Sabi ko, sir, ito yung bahay. Okay? Di-design ka ng bahay, no? Engineer, meron akong bahay dito. So, gusto mo sideline? Ha? Ano? Hello? Yes? Nakikita niyo ba yung Revit?
Yes,
nakikita niyo yung Revit? Okay.
Yes, po, sir.
Yan, so, ayan, sir, ito. Ayan, sabihin sa'yo, engineer, gusto mong sideline, ito, meron ng sideline dito. Di-design ka na ng ventilation system sa toilet. Kita ka na, toilet lang. So, ngayon, ito yung bahay, okay? Ang ganda-ganda, no? Revit, ito yung Revit. Kaya kailangan nyo talaga ng ma-upskill nyo. So, ngayon, ito yung plano. Yan. So, sa second floor, meron kang 4 na banyo. Okay? Sabihin ko sa inyo, exam nyo ha, gagawin nyo yung master bath. Gagawin ko itong bedroom bath na to. Gagawin ko to. Itong gagawin nyo mamaya. Okay? So, ngayon ay ano bang ang sukat nito? So, sir, paano magsimula? Okay. So, ang gawin natin, susukatin natin yung area. Okay? Sukatin nyo. Paano ba sukatin yung area to? It's length times width lang naman. Pero sa Revit, napakaganda. Hindi mo na kailangan mag-isip. Okay? Pag-clinic mo yan, pak! Yun, no? Area, doon na, oh. Nakikita nyo? 3.98. Nakikita nyo ba yun? Nakikita nyo to? Ngayon, so ano ba ang solution? Di ba? Ngayon, ang Q is equals area times height times air change. Okay? Di ba? Okay? So, area times height times air change. So, makikita nyo, ano ba ang height? Kasi anong height? So, tingnan natin. So, sukatin natin. So, sukatin natin. Pag clinic natin to, kakat tayo ng section, click natin to, tapos, click natin to, boom! Ayun, section. Anong height nga? 3 meters. Diba? Panis. Oh, pwede mo siyang ano yun, sukatin dito. So, nasa 3 meters siya. Gawin natin siya 3 meters. So, 3 meters. So, meron ka ng volume kasi area times height. Tapos, anong air change? Okay. Sabihin natin, Singapore. Sa Singapore, ang toilet, 10. Okay? So, sabihin natin 10. So, 10 air change. So, meron ka ng 3.98. Calculator kayo ha. Check nyo to ha. 3.98 times 3 times 10. Anong sagot? Hello? Ang sagot? Aaron, Joaquin, Rive.
119.4.
Okay, good. No? Convert nyo sa liter per second. Okay? Divided by 3.6. Divide nyo sa 3.6. Ano sagot?
33.16 liter per second.
33.16 liter per second. So tama ako. 'Yun. So 33.16 liters per second. So yan yung airflow nyo. Oh, galing mo na engineer. Na-compute mo na airflow. 'Yun ang sukat ng fan mo. Okay? O, di ba ang dali? O, pera na. Okay? So, ang mangyayari, ano ang duct size mo? Okay? Duct size mo. Anong duct size? Okay? Sa duct size natin, nakita nyo ba yung PDF ko? Ito yung type ko? Nakita nyo ba? Yes or no?
Yes, sir.
Okay, okay. Good. So 33 liters per second yung duct size. Okay, so maliit lang to. Gawin natin, ayon sa SIBSE, sabihin natin mga 4 meter per second lang. So, itong 33.16 liters per second, convert pa natin ulit ng cubic meter per second. So, magiging divided by 1,000, Point? Divided by 1,000? Point?
0.33.
0.33 and 6. Okay? Cubic meter per second. Okay? So, yun na yun. So, ito, cubic meter per second, duct size. Oh, panis. Oh, divided by, divide natin to. Divided by divided natin ng 4. Divided by 4. 4 meter per second. Ano napansin nyo? Ano napansin nyo sa ano? Ano napansin nyo? Cubic meter per second divided by meter per second. Ano matitira?
Area.
Tama! Area. Pera na to ba? Oh. Ito nyo, kakalculate lang kayo, pera na kagad. So, ano na? Anong sagot? Anong sagot? 0.03316 divided by 4.
0.00829 meters, square meters.
0.00829. Check nyo ha. Hindi ako nagkakalculate ha. Anong unit?
Square meter, sir.
Square meter. Oh, square meter. O paano gagawin natin? Paano natin drawing to square meter na to? Anong duct size? Anong gagawin nyo?
Square root.
Square root. Anong square root? Anong square root? O yan, square root.
0.091.
0.091. 91. 0.091. 1091 by 0.91 mm. Tama? Meter to, meter. Meter. So, gagawin natin mm. Anong magiging, pwede natin i-round off, magiging 100 by 100 mm. Kuha? Kuha ba? Wait, di ko yung nakikita. Kuha ba? Yes or no? Raise hand. Kuha ba?
Yes, sir.
Di ko nakikita raise hand. Raise hand kung kuha. Okay So, nasusundan nyo pa. So, 100 by 100 mm. Okay? Okay, sagad din na natin. Anong grill size? So, grill size, sabi, kailangan 2.5 grill size. Kailangan, same, kasi isa lang naman ang grill nyo. Kung dalawang grill nyo, divide by 2. So, kung isa lang ang grill nyo, kailangan nyo lang same airflow. So, divided by, ilan meter per second? Sinabi ko kanina, ilan meter per second na grill?
2.5.
2.5. Very good. So, magiging area? Anong area? Anong area? Anong area, guys? 0.03316 divided by 2.5. Oy, galaw-galaw. Anong area? Anong area?
0.01326, sir.
Ha?
0.0132.
0132. Okay. Anong size? Square root. Uy. Square root.
0.15, sir.
Ha? 0.115. 0.115. 115, walang 0 ha. 115. Wala naman 0.115. sa ano, market. So gagawin niyo siyang 150 by 150. Divisible by 50 mga grill. Oh, pera na. Grill size, meron na kayong grill size. O ano pang kulang natin? Louver. Okay, louver. Louver. Same flow rate. Oh, dali oh. Louver. Oh, anong area? I-divide natin sa kumari ang architect 0.50% yung opening. I-divide natin sa divide natin anong velocity? Anong velocity?
Mamaya na usapan natin. Ano ba nangyari doon?
Anong velocity? Mute nyo. Anong velocity? Louver? 2.5 din. Louver. Kaya lang, meron tayo ditong, pagdating dito, 0.0312, meron kayong free opening area at 50%, gagawin siyang 0.5. Walang area to. Okay, so 0.132 divided by 0.5. Anong sagot?
0.0264.
0.026. Ano? 26? 264. Meter square. Nakikita niyo ba yung ano ko? Solution ko? Nakikita niyo ba yung solution ko? Ayan, okay. So, 0.264 meter square. Anong mm? Anong size? Ano? Square root? Square root. Ang square root, guys. Guys.
0.163. 0.162.
163 na lang. 163. Okay. Eh, wala namang 163 sa market. So, gagawin niya siyang 200 mm by mm. Okay. Tapos na. Pera na to. Oh. Ngayon, sir. Paano namin drawing yan, sir? Diba? Di lang yan. So, meron kayong anong natin? Anong grill size natin? 150 by 150. So, the drawing tayo ng 150 by 150. Tayo ng ito, exhaust, 150 by 150. Tapos, di ba, liit? Siyempre, pag-aaralan nyo, saan nyo pupunta? Saan ba usually dapat humigop ng hangin?
Water closet, sir.
Water closet. Bakit?
Sa amoy, sir. Sa amoy.
Yes. Okay. So, 3 meters. Anong ceiling natin? 3 meters. So, lang ba? kailangan 3 meters siya. Nawala. Ayun. Yun yung ano natin. Nakita, wala ako nakita. So, wait lang. Ayun, visibility. Napaka-powerful tong repeat na to kasi nakikita nyo na lahat ng ano, system. So, gawin natin siyang coordination. Apply. So ito yung guys, ito yung diffuser nyo. So kukonekta tayo dyan. So draw duct. So ano ang duct size natin kanina? Ang duct size natin? Duct size natin ay 100 by 100. So, wait lang lolo ko yan ako. So may duct size tayo dito. May duct size tayo dito, meron tayo ditong grill. Tapos, magdo-drawing tayo ng duct size. 100 by 100 dito. Okay. Papunta dito. Saan? Papunta sa bintana. Siyempre, wag natin anuhin. Hindi dapat nakikita, wag sa bintana. Dapat iiwas tayo. Medyo gigilid tayo. Duct routing is an art. So gigilid tayo dapat. Tapos dito natin anuhin. So dito natin anuhin yung louver. Anong size ng louver natin? 200 by 200 ba yun? Anong size ng louver natin? 200 by 200. So ito, sabihin nyo sa drafter nyo, kung hindi kayo mag-drawing, sabihin nyo lang, ito ay 100 by 100, anong airflow? At sabihin nyo lang, drafter, pag-drawing mo ako, ito ay 120 cmh. Huwag nyo nang gawin yung 119.4. Hindi naman nasusukat sa site yan. Okay? Tapos, drafter, ito ay engineer tayo, hindi tayo drawing Kaya lang, maganda din kung mayroon kang knowledge. Kasi, kung wala kang drafter sa sideline, hindi ko na mag-drawing. Di ba? Di 100 by 100 yan. EAD, electric exhaust air diffuser. TED, toilet exhaust duct. Tapos dito, sabihin mo ay, ano sukat nyo? 200 by 200 at at 120 cm. Okay? Tapos, saan nyo dapat ipwesto yung fan nyo? Dapat ba sa room? Dapat sa bath? Saan nyo dapat ipwesto yung fan nyo? Dapat hindi basta-basta Saan nyo dapat ipwesto yung fan nyo?
Sa duct, sir.
Dapat sa toilet. Kasi sa toilet. Bakit sa toilet? Dito dapat nakalagay yung fan nyo. Bakit? Kasi any scenario, maintenance, dito sa toilet. Alam naman dito sa bedroom nyo, gagawa yung mga maintenance guy, di ba? Siyempre, doon na lang sa bathroom. Tsaka bakit sa bathroom? Para yung noise nananatili lang sa bathroom. Gets nyo? So, kailangan isipin nyo lahat ng mga ginagawa nyo sa pagdidesign. Nagigets nyo ba? Nagigets ba? Raise hand. Nagigets ba?
Yes, sir.
Yes. Okay. So, may tanong ba dun paano ko diniscuss mag-design? Kasi ito gagawin nyo. Okay? Pwede yung assignment. Kaya lang madali lang naman 10 items. Ayun. Wait lang Tsaka feedback form. Habang nagpe-prepare yung next speaker. Ayan, feedback form tsaka ano ba to? Tsaka evaluation. Okay? So, may tanong ba dun sa kung paano sinold? May tanong ba? So, makikita nyo sa chat? Nakikita nyo sa chat? Nakikita nyo ba sa chat? Wait lang. Chat. Nakikita nyo sa chat? Yan ang evaluation form nyo. 10 items lang yan. Okay? 10 items. Yan ang exam nyo. Madali lang naman. Kung paano ko kinalculate yon, ganun din dito. Tapos guhit-guhit lang naman. Okay? Okay, nakita nyo ba? Nakita nyo na tong form?
Yes, sir.
Okay. Ano lang yan? 10 minutes o 15 minutes, kaya nyo na yan. Okay? Walang maling tanong, walang Kasi pag mali kayo, may explanation. Ano yan? Kaya sagutin yan base sa inyong knowledge. Then, after nyo sagutin, ito personal ko to. Maliban to sa sa DMMMSU invitation form. Ayan. Sagutin nyo din yung feedback. Technical seminar feedback. Okay? Yan. Okay? Any more questions? Kung wala, ayun. So, you can answer your evaluation for 15 minutes. Pwede ba makingin? Yes, I can give you my presentation in PDF.
Sir, question.
Yep.
Pahabol.
Yep.
Sir, pwede akong mag-share ng ducting?
Ha?
Pwede akong mag-share ng ducting per area? Like, halimbawa itong dalawang bath, master bat saka yung bat
Wait.
na kinompute mo ngayon?
Bakit tayo kung pwede mag-share? I advise
Yes,
not.
sir.
You know why? I advise not. Why? You know why? Because pero pwede ka makatipid. Pero I advise not kasi whatever happens to the other room, alam mo yun, maapektuhan yung kabilang room. So kung may amoy sa kabila, alam mo yun, foul smell or something maamoy din sa unless maglagay ka ng non-retent damper. Pero pwede mo siyang pagsamahin. Pwede, but I'm not recommending. Pero pag sinabi ko sa kliyente, okay, pwede ko pong pagsamahin, pero itong pwede mangyari, tapos naano sa email, klaro, okay, sige, pag may nangyari ganyan, di kita sisihin. Pag may ganon, pagsamahin mo. Gets mo?
Yes, sir. Yes.
It depends sa kliyente yan. Kasi pag may nangyari, uy, ba't ganito engineer? Palpak ka, palpak. Hindi. Ito pinag-usapan natin eh. Mangyayari yan. Pero, sinabi mo, okay lang. Wala na
But
silang
sir, pero kung ganun yung mangyayari, sir, yung computation ko ng fan,
madadagdagan. Yes.
Madadagdagan.
Yes, igagawin mo yung nakuha mong airflow sa bat 2. I-share ko ulit. So, yung nakuha mong airflow, sa bat 2, yung nakuha mong airflow dito, nakuha mong airflow dito, yun yung magiging size ng fan. Plus.
Okay, copy, sir.
Okay? Tapos, pero yung airflow ng diffuser mo at exhaust grill mo dito at exhaust grill dito ay magkaiba. Okay? Magkaibang airflow to kasi magkaibang area.
Yes, sir. Depende sa space din.
Yes. Okay? So, meron akong question dyan. Meron akong 6 na elements, 6 na parang hindi problem solving. Tapos 4 na question na problem solving. Which is itong master bat. Okay? Tapos pasagot na lang yung evaluation form. Okay? Ayan. Klaro ba?
Yes, sir. Thank you.
Okay.
Yun po. So, thank you po, sir, Engineer Arriola. And then po, we are finished with the question and answer portion din po. We will proceed na po to the giving of Certificate of Appreciation po, sir. So, may I call on our Vice President of Internal Affairs of the PSME Student Unit, Mr. Joel Christian E. Viernes, to award the certificate.
Good afternoon. As our way of giving thanks for accepting our invitation, as a speaker for today's webinar, we would like to give this certificate of appreciation to Engineer Klaus M. Arriola in grateful acknowledgement for imparting his invaluable insights and worthy presentation as a speaker on the topic of mechanical ventilation design process in the national webinar organized by the Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University, Midla Union Campus, Student Unit on February 20, 2022. Given this 20th of February 2022, undersigned by the PSME Student Unit President, Mr. John Abel R. Deliso, the PSME Student Unit Advisor, Engineer Talmati Obilio, the COE SBO Advisor, Engineer Sherwin L. Mosomos, the ME Department OIC Program Chair, Engineer Melchor Amiana, and the College of Engineering Dean, Dr. Lorenzo L. Bacani. Once again, thank you po, Engineer Klaus Arriola, for accepting our speaker invitation. Thank you po.
Yeah, it's my pleasure. And for those, yung mga ibang schools, mga state universities, if you want me to present something, or other subject, other topics, let me know. Then I'm okay to present through Zoom sa mga state universities sa provinces, Visayas, Mindanao, and Luzon. Yeah. Okay? You can contact me at my messenger, close Arriola. Yeah, if you have any questions.
So thank you po once again, Engineer Arriola, for imparting your knowledge and your experiences with us. So thank you po. And may we have this opportunity to have a picture taking with you po for a commemoration for your presentation po. So may I invite everyone to please open up your camera and let's have a picture taking. Yung po mga dating gawi po natin. So may you please open up your cameras and let's see those faces. All right, I'm just gonna check just a few scan. Yes, yung ayos na kayo ng buhok. I can see a lot na nag-ready na. Okay. Right, so meron pa po tayo hindi pa nag-open cam. Okay, so kindly open up your cameras, please. All right. Hindi pa tayo nagsisimula, but I already see a lot of you smiling already. That's good. That's good energy. Okay po, so mga iba po, let's open our camera. Okay, the quicker you open, the quicker we're gonna move on to our next part of the event. Okay, so ready na ba? And for our tech team, are we good? Okay. So, in a count of 3. Okay, so ano pala tayo? We have a lot. So, bear with me. And, syempre, kailan naman tayo ng full load smile, right? So, let's start. Okay, so we have 5 shots. Okay, we have 5 different shots, okay? So, in a count of 3, you have to smile. Okay, so 1, 2, 3, smile. Okay, one more. 1, 2, 3, smile. Okay, isa pa. For the third, 1, 2, 3, smile. Alright, at kilala na siguro ako ng mga iba dito sa ating 4th and 5th. Let's do a creative shot, okay? So you can do whatever. Alright, so the count of 3, 1, 2, 3, smile. Okay, so we're already good na daw. So it's only 4 slides. So we're good to go. All right, so thank you, Engineer Arriola, and thank you for our students for participating. And for the attendance will be posted later on. So a little bit, so mamaya po, abangan nyo na lang po yung post-evaluation form. Okay. So heading on. Let us proceed to our introduction of our second speaker. So, sino nga ba siya? So, our second speaker for today is graduated from the Technological University of the Philippines with a bachelor's degree in mechanical engineering, and he has a postgraduate diploma in research and development management from the University of the Philippines. He is currently employed at the Continental Automotive Singapore as a mechanical project leader with 18 years of experience in mechanical design, project management, research development, He is the current chairman of the Philippine Society of Mechanical Engineers, Mechanical Design and Fabrication Technical Division, and the current president of the 69th PSME Singapore chapter. Okay, without further ado, for our second speaker with the topic of mechanical design in product development industry, and the 69th PSME Singapore chapter president, Engineer Adrian S. Makasakit II.
Hello, good evening, good afternoon. Good afternoon, everyone. So, can you hear me clearly?
Yes, sir, loud and clear.
Loud and clear now. So, first of all, I would like to thank you everyone for staying, for this topic, and I hope na marami kayong matutunan. So, I will start my presentation by saying actually I like this so-called merging ng topics because it is actually the second, how do I put it like, kita ba? So kasi di ba meron tayong tinatawag na thermodynamics, So yun ang side na pinasent ni Engineer Klaus. So more on power plant or those air conditioning HVAC. And yung side ko naman, it's more on mechanical design, pero focus na siya sa topics natin related sa machine design, mechanics, geometry, and everything. So, magkaroon ngayon ng different perspective because yung kay Engineer Class is more on large scale design, buildings, construction. But when it comes to mechanical design, it's more on small scale, precision. Talagang pinag-uusapan natin dito is talagang micrometers, millimeters, so maliit siya. So, it's a different side or different spectrum sa mechanical. Kasi napakalawak na natin, di ba? Industry natin or field natin. So, on top of that, meron sa mechanical design, meron pa rin focus yan. Also dedicated sa specific industry. So, this topic is very particular, specific siya sa mechanical design in product development industry. So mainly this is an introduction to students that para this can be as perspective or prospect nyo, lalo na din sa mga engineers na who like innovation or creative. So this can be a good, I would say, career for you. So take this in consideration, be open, and just listen. Sakali may mapul. Alright, so firstly, I would like to reintroduce myself. So again, my name is Adrian. I'm a mechanical sub-project manager with 18 years of industry experience. My specialization is talaga mechanical design, project management, and research and development. So as mentioned, I'm president ng PSME Singapore and the current chairman of mechanical design and fabrication. And I had my startup ng ESM Engineering Services. And currently, I am pursuing my MBA. And also, I have my certification in project management from Project Management Institute, USA. And I have also had my graduate diploma in research and development kasi I'm focused napalinya na ako sa research and development when I moved dito sa Singapore. And I also had some various certificates, and I'm a graduate of Mechanical Engineering at Technological Institute of the Philippines. Okay, so during my free time, I like cycling, jogging, and playing sports. Pero siyempre, alam naman natin, during pandemic, medyo mahirap. So, yung group sports, so nag-resort tayo sa mga mga individual sports like cycling and jogging. And during free times then, naroon din naman tayo mag-relax through darts, online games, and reading. So, I hope this will give you some insights kung who I am or what I do. And let's start. So mabilis lang naman to, bibilisan natin. So 1 hour or 1 hour plus. So this presentation is really targeted
for mechanical engineering students. This is specially designed for you and also for fresh graduates. And aside from that, dun sa mga aspiring mechanical design engineers sa product development industry, this is also helpful and beneficial for them. And yun sa mga without engineers without mechanical design experiences, even though they are experienced, pero gusto rin nilang mapunta sa design, pwede rin sa kanila. Okay, so hopefully by the end of this presentation, you should be able to identify the whole core knowledge in mechanical design, yung mga skills and competencies na kailangan nyo ipunin o kumbaga right after graduation. Hopefully may checklist kayo, okay na-achieve ko na to, meron na ako skills and competencies na to, then I can lean towards the mechanical design field. Pwede kayo mag-apply dyan. And also, by the end of this presentation, you should be able to describe the fundamental product development process. So, meron kasing process yan kung paano ko magde-design hanggang sa mass production. So, napalinya ako sa manufacturing, research and development. So, ito yung so different mindset naman, different school of thought, kumbaga. So lastly is to recognize different engineering solutions from different case studies. So I'll give you some case studies na ginagawa ng typical design engineer o mechanical design engineer sa product development. Okay, so this is the course outline. I will be tackling the mechanical design and product development for probably about 10 minutes. So we will also be discussing technical knowledge, skills, and competencies of a mechanical design engineer. And we will move on after that. This is a general product development process from start to finish. And we will also maybe mute lang. We will discuss now your actual experiences, applications, and case studies. And yung last two is more on para sa inyo to. So I will be discussing some experiences, opportunities, and challenges in this profession or in this line of work. And I'll have some concluding remarks for you. Okay, so part one is mechanical design and product development. So what is product development? So product development is the process required to bring a product from being a concept through reaching the market. So sa Tagalog, ibig sabihin meron ka naisip na produkto, and then paano mo siya ma-realize na may palabas sa market o sa consumer para magamit ng mga consumer. So that is the main concept lang. Very simple, pero maraming dapat himayin. So product development. So may I know, so maybe so maybe one or two students here. So pag sinabing product, pwede ba kayo magbigay ng example? So when it comes to product, example lang naisip ninyo? So maybe volunteer lang, just to be quick. So what product do you think? At first, sa isip.
San Miguel Beer.
Say again, ano yan? Yes,
San Miguel Beer po.
San Miguel Beer. Yan, yung mga tawag nito. Pwede rin yun. So pag sinabi San Miguel Beer, ang mechanical doon, ano sa tingin mo ang mechanical doon sa San Miguel Beer? Yung bote, di ba? So that is mechanical design. So that is also mechanical design. So okay, so what else? What else yung naisip niyo pa?
Car parts po.
Car parts. Ayun, car parts yan, marami, di ba? So lahat basta anything physical, anything physical involved ang product development. So katulad ng pinakita na engineer class, may mga fans siya na pinakita, di ba? Mga different design, different impeller design. So kasi siya system level, di ba? So pag product development o product designer ka, ikaw ang gagawa ng fan na yun, fan assembly. So ikaw magde-design. Okay, so I hope mas malinaw na ano ibig sabihin. So example, yung mga cellphone nyo. Yan. Cellphone, mouse, headphone, ano pa ba, yung mga injection, lahat yan. Not anything that is physical, may mechanical design yan. So just to be, para ma-enlighten kayo. So lahat ng ginagawa dyan sa buong mundo, anything physical that we can touch, may involvement ng mechanical design engineer. Okay? So now let's move on. What is mechanical design? So sabi ng si Shigley is mechanical design means the design of components, system, and system of mechanical nature machines, products, structure, devices, and instruments. So napaka-broad, no? So katulad ng laban niya, talagang lahat eh. Even yung mga tiny components, kayo pa rin, no? Mechanical pa rin na magde-design niya. So from system all the way down to the detail. So yun lang, maganda talaga nagkaroon kayo ng perspective niya, no? Yung sa presentation engineer class, which is on the other side of the spectrum ng mechanical industry. Okay, so let's move on dito sa component design. So pag sinabing component design, ito yon. So gagawa ka ngayon ng mga simple components, kumbaga. So kunyari mga bracket, even yung mga sa computer ninyo, di ba? Yung mga casing yan. So mechanical design engineers ang nagko-conceptualize, no? Up until to the mass production. And hindi lang naman siya sinabing just a box na ganyan. So marami ka pang dapat i-consider sa pag-design niya. So later on, we will be discussing those points later on. So meron yan mga plastic brackets, metal brackets, and plastic casings. So mainly metal, plastic, rubber, mga aluminum. Yeah. So different kinds of materials. Yan ang mga usually na dinedesignin when you enter this industry. So I believe sa ninyo, sa mga klase ninyo, you were taught, no, yung mga calculation, no, yung mga calculation ng sa machine design. So tinitingnan ko nga rin dito yung dating reviewers. So may mga tinuro about springs, bearings, yan. So, but those are only parang liit lang na parte ng buong design, no? Okay, ano pa? So pag sinabing module design naman, so nag-scale up siya ngayon. So from parts, lalaki na ngayon. So for example, yan, ikaw na magde-design ng yung mga engine, or mga maliliit na sub-assemblies, yung mga components sa kotse, or even sa mga machines, no? May mga sub-assemblies, no? Or kung napunta ka sa aerospace industry, maaari mo, you'll design those, yung mga big components yan. No? So it depends kung saan industry ka mapapalinya. So it's either automotive industry, aerospace industry, ano pa ba, nuclear or consumer electronics, biomedical. So napakalawak talaga, marine. So it depends on yung anong tawag nito, limitless ang opportunities dito sa industry na to. So of course, pag pinagsama-sama natin yung mga components, magiging module, di ba? At pag nagsama-sama natin yung modules, so it becomes a product, no? So an example of a product, kahit na ito lang, yung mga simple drills, or yan. So it's composed of thousands, I think thousands of, even hundreds of mini components, no? Mini parts. No? Even yung cellphone, or yan, katulad na sinabi ko, headset, no? These are products. No? And yung mga sasakyan, di ba? Yung mga sasakyan, yan yung mas malaking product. Yung sa aeroplano, yan ang mga large scale. Sa consumer naman, yung mga printers, yan, mga ganyan, or whatever, anything lahat. Marami talaga. So anything na talagang makawakan mo, i-design yan ng mechanical engineer. So at least sa physical, yung sa mga physical aspect. Okay, so hopefully malinaw. So again, these are the top 3, no? Yung product development, mechanical design, component design, module design, and product design. Bakit natin to ina-highlight? So along the way sa sa career ninyo, magsisimula muna kayo sa perhaps sa component design, and then depende naman sa sa industry na mapapasukan or sa business, maaring mapunta kayo dun sa B2B or business to business, maaring modules ang susupply ninyo. Pag napunta naman kayo dun sa B2C or business to consumer, maaring product na yung i-design ninyo mismo. Okay? So there are 3 different levels, at least in my opinion. Okay, so some examples of my design portfolio. So I did not design this, itong mga sasakyan na to. So these are from the car makers, the mga customers namin. But most of the na-design ko is dito sa internal, sa internal or interior products. So for example, itong mga radio or navigation, itong mga climate control systems, and then we have here yung mga head-up displays. So it depends. It depends kung saan kayo mapapalinya talaga. So imagine, ang dami-daming pwede kang mapunta sa seat, pwede kang mapunta sa engines, chassis, or even sa hood. So napakarami. So lahat yan, it will involve your design skills, mechanical design foundation, lahat. So yan. What else? So apart from that, so napalinya rin ako sa consumer electronics. When I say consumer electronics, so ito, mga nagdi-design ng TV yan. So yung mga casing ng TV, and then yung mga audio components, yan, mga soundbar systems or mga mini components and washing machines. Ayan, yan. So meaning to say, kami nagte-test, so kayo yung gumagamit as consumers. So I hope na satisfied kayo dun sa mga performance nila. So because yung mga performance nito, big influence ng mechanical design. So if a good mechanical design engineers, they have to design robust products. That is the number one thing that you will do. But then how you will design a robust product, later on we will tackle on those. Okay, so saktong-sakto, part 2 na tayo. So again, this will be quick lang naman. So just an overview. So what are the technical the design knowledge, skills and competencies na kailangan nyo pag-aralan ngayon? So dun sa mga graduating. So what will you do as a mechanical designer? So pwede mag-volunteer na lang. So isa or dalawang students, what do you think are the roles and responsibilities pagka naging mechanical design engineer ka? So just volunteers. So who can volunteer to anything? No? So what do you think will be your role? So when it comes when you enter the industry. Okay. So wala? No idea?
Sir.
Yes.
Sir, designing the mechanical mechanisms of the module designs or component designs po.
Yes. Isa yun, no? So isa yun. Tama yun. So yun sa mga motion, no? Yan. Part yun na magiging responsibility mo. Okay. Ano pa? Meron pa ba kayong naisip? So yan, motion analysis. That's one, okay? Good. That's a good input, no? So any input, other inputs? Yes. Go ahead.
Sir, to design a mechanisms and provide some simulations, for example, the stress analysis and motions analysis, etc., to provide an accurate graphical representation of the product.
Yes. Okay. Tama yan. So that is a portion lang. That's a portion of being a mechanical designer. So you will do the simulation, no? Not only perform, you'll have to analyze. And when I say analyze, you have to evaluate ano ba yung mga counter proposal. So hindi naman pwedeng niran mo lang yung simulation and that's it. So what will you do? What will you do to improve? What will you do to solve the issues? No? Hindi pwedeng most of the time pagka nag-run ka ng simulation is may failure yan most of the time or hindi up to spec. Unless talagang napaka-experience mo na alam mo na agad yung behavior ng system. So again, when you run simulation, you have to analyze, evaluate, and propose. No? So in order para valuable ka sa organization. No? So you have, no? So okay. So let's go. So ito pa yung mga ginagawa mo. So in general, no? So this is what you will do. So part yun ng feasibility study, yung sinabi ninyo. So simulation, that is part of the feasibility study. Part design. So when I say part design, katulad ng nabanggit, is kung paano mo i-design yung mismong component, di ba? Siyempre hindi naman gagawa ka lang basta-basta ng simple profile, di ba? So marami kang dapat i-consider dyan. Example, yung functionality, yung robustness, no? Yung manufacturability, yung tinatawag nating assemblability, no? Kung paano siya ma-assemble, or even yung serviceability niya after market, no? That is also part of it, no? Yun. Again, so meron din assembly design. Katulad na sinabi kanina, emotion, di ba? So that's part of assembly design. Kasi when it comes to assembling the full product, so you have to understand the motion. Paano ba yan i-assemble, di ba? And yung ano rin, yung syempre yung function. Okay, so then yun, yung virtual simulation, yun ang binanggit kanina, di ba? That is one. And just like engineer clause, no, yung pinakita niya kanina, we will do some simple calculation then. So simple calculation. Kung kanina ang golden formula is QAV, di ba? Dito sa most of the time dito sa mechanical design is yung stress, no? Stress is force all over area. So diyan ka lang iikot, no? And then drawings. So you have to do the drawings. So and maybe unlike sa industry sa construction, no? Dito sa mechanical design, sa product design, you will do the drawings by yourself. Because the reason being is this is the way how you will communicate, no, yung thought process mo. So pag nag-design ka ng isang produkto, meron kang thought process dyan. Bakit mo siya dinesign ng ganun? So how will you convey those message is through drawings. Okay? Ano pa? So you will do the bill of materials. Ano ba yung ibig sabihin ng bill of materials? So yung part list, so yung lahat ng pyesa. Ano ba yung mga lahat ng pyesa sa isang buong produkto? Ikaw yung mag-design yan. Ikaw yung mag-list niyan. Meron ako nakita dito saglit lang. Meron ako nakita ko lang sa GrabCAD. Meron siyang part list, ano? Saglit lang. Meron siyang parang part list na yan. Dito, hindi yata ito. Ano lang, just a disclaimer. Nakita ko lang ito dun sa meron siyang part list sa drawing niya. Actually, wala yata. So, anyway, you will be you'll put those part list sa drawing din, okay? Sige, later on na lang, okay? I'll go back to my presentation. No? Mabilisan ko na lang siguro para ano. Then, yung problem solving. So, when it comes to, katulad ng binanggit ko, when you hit a hurdle, tinatawag na hit a hurdle, may problema, hindi mo ma-solve agad yung issues. Pag sinabing problem, ano ba yung iniisip natin na problem dito? Ibig sabihin is hindi mo may requirement ang customer or ang ibang department, di ba? So you will have to solve those issues, or sometimes naman meron kang design intent pero hindi mo siya ma-meet. No? So you have to do problem solving. Then you have to do risk assessment. Yan. You will also have to do part inspection. So meaning to say, syempre dinesign mo siya, lalabas siya. Kaya sa inyo yata ngayon is more on 3D printing, di ba? So pagka nag-design kayo, you have to validate using prototypes, using 3D print. Then you have to do part inspection, whether those components or parts or assembly comply or within your design or specification. So you will have to do product testing, meaning dapat yung dinesign nyo, ma-fulfill niya lahat ng mga requirements na sinet ninyo. Yeah? And then you will have to release as well yung parts. No? For example, nag-design kayo, and then manufacture na, and then pupunta na sa mass production. No? And then another one is you will have to talk to vendors, no? And colleagues. And you have to do production support. So marami. So just to give you some idea, no? Hindi lang design ang role nyo. So napakarami, napakalawak. So I guess within this presentation, magkaroon kayo ng wider perspective. No? Ano pa yung mga dapat nyong i-reinforce, no? Sa skills and competencies. No? So let's take a look. Pagka tumingin kayo sa, let's say, job street, no? Job street or any job portal, pag gusto niyo mapunta sa field na to, ito yung makikita niyo typically. No? So you have to design mechanical components using 3D CAD software. You have to do calculation and analysis studies to guarantee proper fit and function of components. And you also have to do potential design failures and root cause analysis, design drawings again, and ensure timely completion. Ito yung schedule. No? So pag designer kayo, hindi ka lang kayo sa technical, kailangan nyo rin i-maintain yung schedule. You have to keep track of the schedule, and you have to do self-management. So when I say self-management, you have to know yung task ninyo, i-manage na mag-isa. You have to be independent. No? I guess as a students or engineering students or mechanical engineering students, I believe meron kayong na-train na tayo to be independent sa mga projects natin. Yan, simulation design, validation test and measurements, and evaluation report. So just parang disclaimer or parang advanced information. No? So pag napunta na kayo sa industry or sa actual sa work, napakaraming reports. No? Mas madalas na mas marami pang reports kaysa sa design. Yan ang katotohanan. So you have to practice na and enhance yung presentation skills ninyo, yung organization skills ninyo when it comes to doing reports and evaluating reports. Okay, so ano naman? So yun yung roles and responsibilities, di ba? So ang tanong ngayon, what are the skills or knowledge, skills, and competencies na kailangan mo? No? So para makapasok ka sa industry na ito or to practice these skills. No? So ito lang is in my personal, I may miss out many, but in my experience, ito yung mga kailangan. So yung sa academics, so meaning sa school, ituturo sa school niyo, respective school niyo, is yung mga machine design, di ba? Mechanics and physics. So machine design, yan yung mga machine members, yung gears, so springs and everything. Diyan yung malalaman yung mga basic formulas. Then mechanics naman yung motion, di ba? Yung motion, yung mga formulas, kasi when you are designing, kasi ang industry ng product design is you are an inventor essentially. You are an inventor, so you are always designing out of nothing. You will start from scratch most of the time. Then you have to also learn geometry. So yung geometry natin, thermodynamics. At least for myself, I know ginagamit ko heat transfer, yung basic thermodynamics. Again, depends on the industry na papasokan mo or sa product na i-design mo. Trigonometry, yan. And kasi syempre, yung material science, kailangan mo yan. So, yung mga elements dati hindi ko pinagbibigyan ng pansin eh. Pero ngayon is talagang kailangan pala siya. So, example, bibigyan ka ng material data sheets. Engineer, pwede ko pang gamitin tong metal na to for this component. So paano mo sasagutin yun kung hindi mo alam yung material properties? Pagka hindi mo masagot, iba na yung tingin sa'yo kasi you are the engineer, dapat ikaw yung nakakaalam yan. You have to justify the rationale, why did you choose those materials? So para sa akin, this is very important, yung material science. So bakit steel, bakit metal, why alloy, corrosion, ba kailangan mo ba ng plating, what kind of plating, many things. Okay. So additionally, you also have to know yung engineering economics. So yung net present value o yung mga costing. Ito malaking tulong sa akin to. Kasi yung pag magko-costing ka ng parts, for example, sa feasibility studies, very important yung business case. As you move further sa industry mo or sa profession mo, mapupunta ka dun sa higher level, syempre. Meaning, dapat ba natin i-go ahead or not go ahead tong project na to. So because of the economics, so yung business case na tinatawag, malaking bagay yung itong subject na to. Yan. So, pag-aralan nyo siya. No? And then yung manufacturing processes, no? Yung machine shop practices, yung injection molding, sheet metal, yan. Marami pa, maraming pang iba. Yung machine shop practices. Yung assembly methods, yan. Ayun, katulad din yan, machine shop practices. So in detail, marami pa no? So, pero hindi natin siya ma-tackle one by one. So this is just an overview. So it's CAD software. So I trust, no, marunong kayo mag-CAD, no? So ito yung personally, ito yung nagamit ko. So 𝐏𝐡𝐢𝐥𝐢𝐥𝐢, and some of my colleagues use SolidWorks, AutoCAD, Inventor, no? And many more. No? Ang payo ko dito is just learn one or two. Kasi when you learn one, it's easy to transition from different CAD software. No? So pagka meron kang isang master, isa o dalawang master, okay na yan. Pag lumipat ka sa ibang company, ano yan pag-aaralan mo rin naman Pero hindi ka na start from zero. So yun ang pinaka-importante. MATLAB, ito yung narinig kong, ano ngayon itong, parang narinig ko siya na ginagamit ng iba, pero personally hindi ko pa siya nagamit. But it's more on formula tayo, di ba? Yung mga simulation expert namin, ginagamit nila yan. Pero myself, hindi. Ayan, simulation software, ANSYS, SolidWorks, and etc. So you have to learn FEA, so yung structural, CFD is yung yung computational fluid, so yung ginagamit ko yan sa airflow, no, sa thermal management. Gumagamit din ako ng mga sa optics, no, o yung sa mga ilaw, ganyan, sa mga ilaw. So doon po pasok yung physics. So yung meron din tayong ganung mga tawag nito mga software. Meron din naman sa mga tawag nito molding, no, sa molding software, sa mga flow red. Marami. Then meron din mga data management software. Ito naman is para mapadali yung mas ma-organize yung mga data management ninyo. Okay, so di ko na elaborate. MS, of course. I fully encourage na paglabas ninyo ng industry, dapat expert na kayo dito sa Excel, Word, and PowerPoint. Ito yung lagi nyo gagamitan. Yung Excel is para mapabilis yung mga calculation ninyo. So usually gagamit kayo niyan. And then yung Word naman is sa report, no, technical reports. So you will have to learn it. And yung PowerPoint presentation naman is sa pag-present ninyo sa upper management, so sa colleagues ninyo, or even sa mga customers or clients ninyo, so and suppliers. No? So napakalaga. No? I couldn't stress more yung yung importance nitong basic lang, pero marami ang nakakaligtang i-focus ito. No? Ano pa ba? So sa industry namin, sa industry ng product development or product design, so these are some of them na kailangan matutunan. So tanong ko sa inyo, so maybe just give me an insight. So pinag-aralan nyo na ba ito dyan sa school? Let's say plastic part design, sheet metal part design, die casting part design, rubber part design, packaging part design, PCB part design, simulation, maybe yes, kinematics, maybe yes, fasteners and joints. Can you give me some insights? Medyo hindi na ako personally, hindi ko na pag-aralan to nung nasa school ako. So maybe just one or two comments. Meron na bang nakapag-aral sa inyo dyan? I just want to know.
Sir, hindi pa po namin napag-aaralan po ata yan.
So meaning to say, as in, foreign siya sa inyo, parang gano'n?
Yes po, sir.
Okay. Okay, thank you very much. Sino pa yung baka may inputs pa kayo. So, as in lahat ito, walang nabigay na inputs or ang school or hindi pa naituro, di ba? Kasi more on pag sinabing product development, kumbaga nag-i-invent or nagpo-produce ng product na from zero, which I think yung country natin is not yet moving towards that. So but I hope in future so yung natin industry natin will move towards that, no? Kasi usually ang nakakaalam nito pag nanonood ako ng YouTube, yung mga nasa MIT, mga nasa big school sila, gumagawa na sila, di ba? Alam na nila agad na paano mag eh. Pero I hope no someday may pasok na rin natin to sa sa curriculum or even sa college lang, even on electives or something like that. No? Okay, so later on, hopefully makapagbigay tayo ng mga trainings nito. Just a simple ones. No? Okay, so isa pa. So meron bang nakakaalam ng mga tolerance stack-up analysis? Meaning to say, kasi ang pinag-uusapan dito sa product design is micrometer. Minsan mas manipis pa sa buhok mo yung tolerance or yung gap, di ba? Or mas manipis pa sa papel. So yun ang pinag-uusapan natin mga tolerances dito. So miniatures. So ang challenge dito, syempre meron challenge yung bigger structures, di ba? Pero may challenge din sa pagka mas maliliit. So hindi natin dapat siyang parang minamaliit na. So yun ang challenge yan is yung how to manufacture, di ba? Yung mga precision parts, no? So kung minsan titingnan mo yung cellphone na yan, yung palit ng palit, di ba? Yung mga camera, palit ng palit. Minsan tatanungin natin, paano nila nagawa yun, di ba? So it has to be some high technology. No? So ito yung mga ginagamit. So simple tolerance stack-up analysis and geometric dimensioning and tolerancing. Failure mode and effect analysis. So dito na tinatawag yung risk assessment. No? So meron mga methodologies dito. So I am not sure kung aware kayo kung paano sila gawin. But hopefully some other time makapaggawa ko ng mga materials na para at least magkaroon kayo ng overview man lang. No? Para pagdating nyo sa industry, hindi kayo nangangapa pag pinagawa kayo ng boss ninyo o gawa kayo ng risk assessment or calculate nyo yung mga tolerance stack or can you interpret yung GD&T. At least alam nyo na, di ba? Kasi pag sinabi nyo ito is universal, no? Most of the time, lahat ng mga nakakausap ko from US, Germany, Japan, Korea, China, Romania, all over the world, no? So dito lang kami umikot, no? We have common languages. No? Okay, so yun, design for manufacturing and assembly. Yun nabanggit ko, you will not just design for the sake of designing, no? Just to your liking. Hindi ganun. So meron kayong ko-consider ng mga stakeholders, no, or other parties, no. Meron ko example kung magde-design ako ng product, and then one of you or three of you will have to assemble it. Siyempre kailangan kong kunin yung opinion ninyo. Ano ba yung mas madali? Ano ba yung mas mahirap na process, no? So yun ang mga some topics na hindi naman hindi nabibigyan pansin, pero to bridge the industry and academe practices. So ito yung way of doing things natin sa industry. And design for Six Sigma. So meaning to say design for Six Sigma. Bigyan ko kayo ng example. Example lang mga cellphone ninyo na Apple or yung mga laptop ninyo. No? Usually magpo-produce yan ng 10 million o even 100 million per year, ganyan, di ba? Per parts, di ba? So pag sinabing 1% ng 100 million ang rejection rate mo, at for example $100 yung part na yan, $100 US dollars per ang cost ng part. So magkano yung rejection rate? Magkano yung reject na yung cost of reject mo? Di ba napakalaki rin? Although pag titingnan mo is 1% lang. Pero pag $100 per piece, di ba? Ang laki na rin niya. So magkano yun, no? So dito sa Design for Six Sigma, what we are focusing is yung robustness. So 0.000 something lang yung rejection rate niya. And almost perfect ang target natin dito sa Design for Six Sigma. It's more on design, robust design ang tinatawag siya. Okay, tear down techniques. Pag sinabing tear down techniques, ito rin yung tinatawag na reverse engineering. So reverse engineering is paminsan, meron ka example, ano yung mga produkto na makuha mo dyan? Example, yung TV ninyo or anything, yung mga motor ninyo, pagka, di ba, pag binubuksan natin, pinag-aaralan natin, di ba, kung paano siya i-assemble, disassemble, ano yung mga pyesa, then that is already a tear down technique and reverse engineering. And then minsan may maisip tayo, dapat pala ito, at hindi nilang kinombine itong 2 or 3 components into one. Same lang naman ang magiging function, di ba? So that is already part of your designed for Six Sigma or design for assembly, no? Or design tear down techniques or reverse engineering. No? Yun yung may mga process, no, na dapat na matutunan dyan. Okay? And yung structured problem solving techniques, meron tayong problem solving process, hindi yung problem, cause, problem required and solution, hindi yun. May mga different processes, no? O yung mga thought process sa industry. Na for example is yung yung A3 na ginagamit. A3 ang tawag nila, A3 problem solving techniques, widely used by Toyota. And 8D is 8D methodology, widely used naman sa Ford or sa iba't ibang industry. Okay? So again, these are some of that knowledge na kailangan nyo matutunan. So bilisan ko na. Pag-design naman ng product, sa product development processes. So from start to finish, ano naman ang mga dapat gawin? So what is this product development process? So what is this? Para mabilis, so ako na magbabasa. So these are the steps required to take the product from early stages in the product development, from idea generation and market research through research and development, manufacturing and distribution. So to keep it parang mas madali siguro, So from idea mo yan, di ba? So idea lang all the way, no? So yung mga processes na yan hanggang sa maging product na and all the way to the market. So that's simple as that. And do you know what is happening, no, sa real world? So ano yung trends na nangyayari ngayon sa when it comes to product development? So yan, robust design for new products. So ito yung mga kailangan ngayon. Kasi pag hindi natin ginawa ito, so what can happen or what can be the impact is we will have product recalls. Kung matatandaan nyo, marami mga companies na nagre-recall ng mga products nila because of safety issues, no? So that is a big no-no. No? Ito yung iniiwasan natin. Ano pa ba? So ang nangyayari ngayon sa product development industry is yung faster time to market. So kunyari, example dati is 24 months o 2 years na dinidevelop. Ngayon, maaring gawin na lang 1 year. Or from 1 year, magiging 6 months na lang. Kasi ang mangyayari dyan is when you introduce a product late sa market, meaning to share, mas marireduce yung market share mo, diba? Market share ng company. Siyempre, lost profit or mas konti yung maaari mo maibenta. So that is the reason why. And also product efficiency and quality yield. Katulad ng nabanggit ko earlier. So when you have plenty or high reject, so you will also lose or reduce your profit margin. So that is mawawala yung mga bonus natin, mga bonus ng mga designers. So that is highly tied sa bonus. And innovation. Ngayon is innovation and technology disruption. It is very prevalent na ngayon sa time natin. So pag hindi tayo natuto na magkaroon ng innovation, so the business will fade and maaaring magsara. So hindi na magbabanggit, pero maraming mga business ngayon na nagsara because of ang tawag nila, hindi sila naka-cope up sa fast changing market, so or market demands and technology. Okay, hindi sila nag-innovate. That is the reason why. So that is the trend. And what are the design and development processes? Okay. So to personal experience, I subdivided them into 6. No? So number 1 is demand, concept, design, build, test, and fabrication or manufacturing. Okay, so bigyan ko kayo ng So maybe just give me some, I would like to hear from you. So pag sinabing demand, ano yung, saan nagsisimula? Ano yung pag sinabing demand? Ano ba yung natin? Nabanggit ko na. Yes. Go ahead.
Kung ano po yung kailangan, sir.
Yun, tama. So, ibig sabihin, may problema ba, di ba? Yan. So, ibig sabihin, meron bang request, no? May request ba galing sa customer mo? Or example sa inyo, may request ba galing sa professor, sa kaibigan, or whatever, no? So, meron bang request na gumawa ng machines or product or design? Yeah. So, that is one. So, meron bang need? Kailangan ba, example, may problema ba na kailangan mo i-solve, no? Meron bang kailangan i-improve? Ayun, so kailangan mo ng tawag nito, meron ibig sabihin, may demand, no? So kasi pagka walang demand, hindi mo naman kailangan mag-design, no? So meron bang requirements, so meron bang problem, no? So that this is the parang trigger, no? This is the trigger, no? To start yung product development processes. So I hope na mas maliwanag siya. So dito sa stage na to, ang major activities is yung situation analysis and problem analysis. So alam niyo ba yung problem analysis and situation analysis? Okay? So situation analysis means ano bang meron tayo ngayon? So for example, meron tayong rice harvester, no? So sa rice harvester, ito lang na harvest na rice per hour, for example. And then para mas gusto natin sana siya mas mapabilis yung harvesting para mas maparami yung output natin per day, no? And then with that, you have to identify yung gap, no? Ano ba yung gap na kailangan and then to improve, no? So that is the situation analysis. And then likewise sa problem analysis, no? Titignan mo kung may problem ba, and then you have to address that problem and then go ahead to the next phase, no? Which is yung concept. So meaning to say, dito mo ma-identify kung go ahead ba tayo or not, no? At least on the business perspective. The next phase is yung concept phase. So meron bang makapagbigay ng insights nila? Anong ginagawa dito sa concept phase? Sige, just feel free, no? Feel free. Nothing wrong, nothing right or wrong, no? So we will discuss. So anong gagawin natin dito sa concept phase?
Brainstorming po, sir.
Yes, correct, no? Tama. So meaning to say, so we'll have to do the research, no? So mas in-depth na. So dito na papasok yung in-depth research ninyo, and then you have to do the brainstorming, sketches, gather specifications, and you'll do investigations, no? So major activities in this tawag nitong process na to or phase is feasibility study, no? So dito na papasok yan. Siyempre brainstorming kayo, di ba? May mga design reviews or ano ba yung mga dapat gawin, no? Anong concept ang dapat nating patunguhan. Kasi ang mangyayari dito, usually sa concept phase, marami kayong options, no? You have option A, B, C, and D. And then you have to have a criteria, no? Ano yung mga criteria nyo? And then you'll have to go to that architecture or tinatawag na concept. Yun. So yun. So pagdating dito sa stage na to, you have to define the architecture. So meaning to say, parang robust na siya, no? Hindi na siya parang na-address na lahat ng mga gaps, no? Or yung mga technical yung mga vagueness sa technicalities, no? Okay, so after ng concept, syempre meron na tayong idea, di ba? Ano ang gagawin natin ngayon? So meron ng needs, di ba? Okay, so may needs na, may problema. Phase 1. Phase 2, okay, alam na natin ang gagawin natin. This is our direction, gagawa tayo ng ganitong machine. Phase 2. Sa design stage, ano ang tingin nyo ang ginagawa? Sige, please feel free, no? Just an input na ano ang gagawin natin sa design phase.
Collaboration po sa CAD software.
Sa suppliers? Collaboration? Pwede naman. Okay. So ang gagawin natin dito is more on detailed design ka na. So kasi syempre meron ka ng architecture. Pag tinawag na architecture, yung high level high level design, no? Pero hindi pa well defined yung mga detail, no? So when it comes to detailed design, so generally papasok yung collaboration mo with different designers. So for example, sa isang design or isang module, no? You can collaborate with 5 or 5 or 10 design engineers, no? You will have to design different components. Ikaw, component A, yung isa, component B. Pag sasamahin nyo, then you have to check those interferences, you have to check the feasibility or yung manufacturability, no? And you also prepare drawings, no? You will collaborate here dun sa mga suppliers mo. So yung drawing mo ba is well understood with your suppliers, with your production engineers, no? Manufacturing engineers, process engineers, no? Ayan, so dito tama yung collaboration, dito na papasok yan. But mainly is detailed design, drawings, and you will have a working model as an output. And you will have your assessment as well dun sa drawings or design mo, which is yung design review. And ang major activities dito is yung finalizing the design. You will have many design reviews, you will have simulation studies, and yung optimization. Pag sinabi natin optimization, meaning meron kang round 1, round 2, round 3, round 4, marami hanggang sa ma-finalize ninyo. So don't be discouraged sa stage na to. Paminsan i-revise mo yan. Abutin ka ng madaling araw sa revise ng mga drawings, no, for design from different comments from different stakeholders, no, like your boss, yung boss mo, or yung ibang department boss, mga yan. Don't get discouraged along the way. Malalaman mo na yung requirements ng company or nung mismong stakeholders na yan. Okay? Designs, okay? So ngayon tapos na tayo dito sa demand. Alam na natin yung concept natin. Nag-design na tayo in detail. Meron na tayong final design. Ano next phase? Next phase na is build. So dito ano nang ginagawa? So maybe ano yung nakikita nyo or tingin nyo ng mga ginagawa?
Ginagawa na po siya.
Oo. So when you say ginagawa, ano yun?
Testing.
Yan. Yung mga diyan na papasok yung prototype or yung prototypes, di ba? Sa inyo yata gumagawa kayo ng mga 3D printing, di ba? Sa mga 3D printing or even paminsan yung mga kahit yung mga paper, kinatlang na paper or karton, that's also called prototypes. So meaning to say, you're now verifying yung design mo. So from 3D model, physically. Kasi paminsan sa 3D model, akala mo okay na eh. Pero yung pala may mga maliliit na hindi mo na-consider. So example, may mga gaps, akala mo okay na. Or yung gravity, the gravity itself, hindi mo na-consider sa design. So, pag sa CAD model, akala mo nominal siya. Hindi gagalaw, pero in actual, nagsasag pala or hindi pala nag-move. So even yung motion, no? Sa motion, paminsan nag-assume tayo na ganito yung motion niya. Pero in actual, hindi pala sa ganun. So you build, meaning we have to do prototypes, and we have to do tooling or yung mismong mold or ito na yung mga pang mass production kasi. And then you have to do yung pilot run. Pag sinabing pilot run, gagawa ka or mag-build ka ng not only one, minsan 5 up to 100, no? Just to simulate kung gaano ba ka easy o yung robustness ng design mo. So yan yun. Okay, so I hope na mas magkaroon kayo ng parang ng insights, no? And then you also do the measurement. Siyempre, pag binuild mo yan, iba't ibang process, di ba? So part A, parang iba ginawa, part B, iba na naman. And then, pagka pinagsama-sama mo yan, may mga variations. So tinatawag natin yung variations. And then, those variations, pagka pinagsama-sama mo, maaaring maging out of spec or within specification. So you have to evaluate, no, as engineers. So in this space, ano yung mga major activities ninyo? So you have to do vendor sourcing. So when I say vendor sourcing, makikipag-usap kayo sa mga suppliers, no? So worldwide usually yan. So China, USA, Europe, Japan, Korea, Taiwan. So you have to you need to develop yung competency niyo sa communication, no? And then the design and development. So that is also that. And in test, no? So test, you have to do environmental. So you have to design, no? Design for robustness. No? Katulad na nabanggit ko. Hindi mo naman yan di-design yung product na yan as a single use or one-time use. No? So most of the time, for example, you have to design it 10 years, no? 10 years na quality, for example, sa cars or 5 years. You know? So meron mga long-term test o reliability test. No? For example, sa kotse, no? So bigyan ko ng example sa car. Yung mga environmental, so kailangan mo i-consider yung material na gagamitin mo. Kasi may mga different tawag nito temperature specs yan. No? So maaaring pag napunta siya sa desert, no? Kailangan mo na high heat components, so high heat materials, high heat resistance materials. Pag napunta ka dun sa let's say sa North America, no? Yung mga freezing temperature, so kailangan mo ng robust. No? So lahat yan consider mo yan sa test. No? Sinisimulate yan. And then your reliability and safety. So here, we are doing the validation test and legal certification. So kung nakikita nyo dun sa mga appliances ninyo or even sa lahat ng mga products, meron mga ano yan, yung UL, CE. So those are the certification bodies. No? And then finally, so once everything is in order, so you have to fabricate or manufacture. No? So you have to do the high volume manufacturing, and then have to consider the processes, so different processes to make the whole thing efficient, no? The whole assembly efficient. And then handling, you have to consider the handling ng mga products and yung components. Yeah? So then logistics, so not only yung incoming, no? When I say handling, not only yung handling ng incoming components, no? But you also need to consider yung logistics from your manufacturing facilities all the way to the distributors ninyo. For example, from Philippines, no, yung factory, and then mag-export, let's say for example, to North America or Europe, then you have to consider that as well, no? Sa pag-design ng packaging or even ng product itself. No? Okay. So major activities here is mass production and quality control. No? So along the way, merong mga mechanical design practitioner dito sa bawat phases na to. No? So lahat yan. So when you enter the industry, usually you have to be well aware o may experience ka. So manufacturing, test, build, design, concept to demand. As a starter, so fresh graduate, most of the time you have to learn muna dito, test, build, design, concept, and demand. So don't get discouraged, no? Pagka nagsimula kayo, no? Syempre as cadet engineers or junior engineers, mapupuntahin kayo sa production line, no? Kasi manufacturing ang concept ng industry ng product development. Pupunta kayo sa production line. So ang ibig sabihin nun is kailangan yung i-absorb lahat ng mga dapat na design considerations sa manufacturing and fabrication. So pag pinadala kayo sa test, no? Kailangan yung i-consider lahat ng mga test considerations, no? Sa build. No? So as you go further on sa career ninyo, sa mapupunta kayo sa highest level. No? Kasi hindi kayo pwedeng almost of the time, no? Mahirap pumunta dito sa first and second, no? Second stage kung kulang pa yung experience. So because it can lead to yung cost incur, pagkaroon kayo ng mga rework cost, no? That can be detrimental to your business, no? Or your company. Yeah. Okay, so I hope na magkaroon kayo ng insights, no? So from demand, concept, design, build, test, and fabrication. So is it clear ba to everyone? So maybe just say yes or no. So do you need more clarification? Just to have your participation here. Yep. Okay, thank you very much.
Yes, sir.
Thank you very much. Okay. So ngayon, nagtanong tayo sa part 4 na. So sa part 4 na, medyo bibilisan ko na, sa alas 1 hour na rin. Bibigyan ko lang kayo ng insights. No? So along the years of my experience, bigyan ko kayo ng mga ginawa ko. Kung paano ko na-apply ang design, mechanical design and development, sa product designing. So sa design stage, so pag-aaralan natin or we will solve a problem using part modification, so part optimization, so choosing an alternative and performance verification. And during the development stage naman, so we will solve a problem using data analysis, testing, investigation, and problem solving. So yung mga technical skills na binanggit ko kanina nung earlier, papakita natin paano siya nagagamit sa industry. So ito, so number one, so design modification. So here, I'm checking the manufacturability and robustness. So meron ako example dito, meron akong design itong bracket, component design, syempre, di ba? So ito yung design ko. I have here bracket, and then let's focus dito sa area na to. So I have here area A and area B. So here, ang nangyari kasi is, itong area na to, after series of discussion with the suppliers, di ba? Nakita natin na this area is weak and non-manufacturable. No? So ibig sabihin, pagka ginawa na yung tooling or yung mold, magiging weak siya. So maraming quality issues. No? So that is the issue here. Dito naman sa B na to, so nakita natin during validation phase. No? So katulad ng binanggit, yung simulation, structural simulation, nakita na weak to. So when you say weak, maaring mag-cause siya ng noise, no? So during vibration, or maaring magkaroon ng breakage or during sa mga reliability test. So what did we do? So change of geometrical design due to weak structures. No? So optimization of geometry using DFM, so design for manufacturing, technical feedback from suppliers. No? So we had a series of discussion with suppliers, no? And we come up with, for example, a new part. No? Ang nangyari kasi dito, we have to introduce a new part. So meaning to say, as I am a mechanical design engineer, kailangan ko i-justify sa management. So okay, we need to add a new part because of these reasons. No? It is non-feasible, and quality and robustness of the part or the component will be affected. No? So the integrity of the whole structure will be affected. No? So that's the reason, sabi mo na, we have to increase cost. No? So that is a way, no, to provide value to your company. Okay, so ayun, so nagkaroon ng cost increase sa BOM cost o part list, pero naman nagkaroon ng quality increase. No? So that is more important. And then dito naman walang cost increase pero nagkaroon ng robustness. No? So nagkaroon ng alternative sa design, no? Na pwede i-connect tong two walls. No? Okay? So I hope nagkaroon kayo ng insights. No? So as a mechanical engineer or design engineers, that's how you can provide value to your company. No? So you have already avoided quality issues earlier on through your knowledge. So ano pa? So check design optimization. So check performance under different steel sheet thickness available. Ang context naman nito, example, nag-design ako nitong bracket. Component ulit siya. And then, initially, this bracket design is intended for US market. No? So, US market siya. No? But along the way, during the feasibility studies, no, the management, for example, decided, okay, in order to be more profitable or to be more feasible, we have to move the manufacturing dito sa Asia side natin. No? So, Asia manufacturing. But ang nangyari, okay, itong component natin, we have a, let's say for example, a thickness, for example, a 2 mm, no? na thickness ng steel sheet. Kapag ka pinadala mo pa yan from US, no, or North America yung raw material, so it will take months, no? It will take months yung logistics nga, and then the price will increase, no? And then yung schedule will be at peril, no? Magkakaroon ng issues. So what is the next alternative? So as engineers, okay, so with the help of the purchasing and yung quality, so we found an alternative. That is an alternative material. No? So that is available in Asia. So that is, pero thinner siya. So mangyari is thinner material. So what will you do as a mechanical design engineer? Sasabihin mo lang ba, okay, go ahead. Just use that material available. ganun ba yung thought process nating engineers, di ba na hindi. So we have to justify. So we have to justify why we have that decision. Hindi pwedeng magde-decide lang tayo for the sake of deciding. So we have to make decisions and we need to have justification. So for here, using simulation, we have justify that even using a thin material, the performance is about the same. So very similar. So we have decided, okay, we can go ahead with this material. So anong nangyari? Nagkaroon pa ng cost savings ang company. And then at cost savings, and then hindi na-apektuhan ng schedule. So everyone is happy. Then that's how you provide value to your company as a design engineer. Okay. So another one, case 3. So design alternatives again. So choose which of the two design options is a better solution. So dito naman ang context niya is nagkaroon ng issue or nagkaroon ng problem. Dito napapasok yung problem solving skills niya. Okay, example, meron problem dito. Yung PCB, nagkakaroon ng warpage or deformation. When we have high deformation, what is the impact? Meaning to say, yung mga components niya, magkakaroon ng high stress. And then when you have high stress, you have a high risk of damaging yung mga electrical components. So that's how the thought process. So meron kang deformation. Ano mangyayari pag may deformation? May high stress, meron kang magli-lead sa failure. Okay, so this is the baseline. Diba? So meron tayong baseline ito. So for example, this is the profile. As engineers, diba, ang dami nating maiisip. Meron tayong proposal A, proposal 1, proposal 2. But then again, same question, same thought process. How can you justify? How will you justify to the management, to your boss? This is the best or better solution. So one way is to use simulation. So here, so solution number 1 is to close natin tong tawag nito itong material, di ba? So pag titingnan mo, di ba, parang at first thought, parang okay to, mas matibay, di ba? Mas matibay siya, di ba? Kasi kinlose natin siya, di ba? Parang mas solid, yun ang unang thought process natin. Pero pag tinignan mo sa simulation, meron palang high stress dito sa area na to. Ayan. And then, meron din naman another solution, na wala kang gagawin. You have to just reduce the screw distance or pitch. And then, yun pala, with just that simple solution, we have a better performance. Who would have thought? Who would have thought that is a better solution? Kung kung imagination or even yung sa parang trial and error. So again, so with this simulation or dun sa natin sa problem solving skills ng as mechanical engineers, as design engineers, so you have a different imagination, creativity. It's just a matter of justifying which one is better when it comes to cost, cost impact, schedule impact, functionality, and then of course yung quality. Okay. Meron pa case study, case study, so designing for thermal verification. Dito naman pasok yung CFD. Paano naman natin to ginamit, as for example, design engineer ka, tinanong ka ng customer mo or whoever, engineer, I have this module. Ano ba yung the best na orientation na ilalagay ko to sa for example, sa machine or sa sasakyan, for instance. What is the best orientation? So paano mo siya ma-justify? Again, same thought process. We need to have a reason behind. And how will you do that? So for this case, we did a thermal simulation. And from here, we can see that kasi yung ang composition nito, this is a plastic component. And the bottom one is a metal component. So as you can see here, yung heat dissipation mo, hindi ganun kaganda kasi may heat ka dyan, may thermal heat transfer ka dyan sa loob. And then magdi-dissipate siya dito. Makita mo dito yung init niya, di ba? So hindi niya masyadong madi-dissipate ang heat. And then dito naman sa case 2, pag binaliktad mo naman, pagka pala hinarap mo yung metal components pataas, makikita mo pala dito na mas maganda yung heat transfer, di ba? So, ayun. And then pag sideways naman, hindi pala ganun kaganda yung flow, no? Yung heat transfer, no? So with this simulation, you can already make a decision. Okay, it is recommended, sabihin mo na this component has to be mounted within in this certain direction or orientation. Engineer ka, so as engineers again, mechanical design engineers, there is a justification or a rationale kung bakit natin dinidesign o bakit tayo driving towards a certain direction. Hindi pwedeng gut feeling or basta-basta lang, no? That is a no-no, no? In my experience, from a junior engineer to experienced engineer, doon ako medyo nagkaroon ng challenge, no? So sometimes, how can I make decisions? Kasi hindi pa naman naturo sa atin sa school yan dati. So, pero yun ang gusto ko may bahagi sa inyo, yung thought process. No? We need to have justifications, we need to have criteria para sa decision making. Okay? And then, ito naman yung design evaluation. So if you know some certain defects, pagka lumabas na yung actual part, no? So from design, meron na actual part, you will not be, para hindi ka matatakot o ano ba natin, in a tactful way. Parang alam natin, no? We have an idea what is happening. So for example, this case, nagkaroon ng issue, sa actual part, nagkaroon ng parang mga drag marks. So kailangan mong sabihin niya sa supplier mo, you have to improve this surface defects. No? And then, with these defects, nagkaroon ng mga issues sa tolerance chain or tolerance stack. So na-identify natin yung issues. No? So we have corrected the part defects. So using understanding the different manufacturing processes. Okay. And we also have here a design improvement. No? So if you know that, if you have knowledge in manufacturing processes, hindi ka basta-basta malaloko, no? Ng mga supplier mo. For example, nag-design ka na flat pala to. But when it comes to the actual part, hindi pala flat. So, pag sinabi nila, hindi na, ganyan na lang eh. Hindi na magagawa ng machines. No? So you have to dig deep, understand the process, and then discuss, no, and collaborate with your suppliers. So for this case, series of discussions, series of tooling modifications, or not modification, but tooling improvements, no? So to come up with within the specification. So yan, nagkaroon na improvement, naging flat. So likewise, you have to define, no? So mechanical engineer, design engineer, so you have to define, define test methods. So again, I couldn't specify nasa inyo manggagaling, no? You are the source of information, you are the brain, no? When it comes to the product. No? Mechanical design engineers, kayo talaga yung mag-iisip. No? You are the knowledge workers here. Lahat magtatanong sa inyo, no? Kung paano i-test, ano yung spec, paano i-improve. Paminsan is overwhelming, no? It's overwhelming. But I think as you go along in this industry, you will learn the experiences, and the next time mas madali nyo na solve yung mga issues. No? So for this case, nagkaroon ng kailangan natin ng pull first, push pull test. So we have done certain tests, no, to identify, no, that this area needs to be improved. No? Okay? So yun naman, na-improve naman along the way. Okay? And then, isa pa yung design verification. No? So you have to do design verification. So walang magtuturo sa inyo. So especially pag napunta kayo sa research and development, so like me, no? Ikaw magdi-decide paano yung test method, no? Kasi dinesign natin yan. So when we design it, so we have to verify, no? And we have to think of certain creative ways, no? How can we, I would say, verify and validate those design. So for this case, for example, meron akong screw. I define the torque, no? The torque required, and the speed, no, which is 300 RPM. Ito yung kasi minsan ginagamit din sa production line, which is standard. So, naglagay ako, so tinest ko siya, which is no damage naman. Pero, yung pala, no, so, walang damage sa screws, hindi siya nag-overrun. Pero yung pala, nagkakaroon ng deformation. So, how do I, paano ko na-figure out, no? Paano ko na-figure out yung issue, no? Paano ko na-figure out? So, ang ginawa ko, nag-plot ako. So, I measured the edges or the points, no, using height gauge, no. So you have to also know how to operate, no, yung mga measuring equipments, no. Sa school siguro meron kayo niyan, no? So yun, so walang nagturo sa akin, walang magsabi sa akin ito gagawin mo. So it is all within as engineer, diba? You have to be proactive, you have to know, no, what to do. So yun ang I cannot emphasize more, no. So you have to be proactive and you are the source of information. Ayan. Then, so na-identify natin dito, meron palang deformation. So, yun. So, what did we do? So, problem solving. So, tinignan natin about what is isang component. We even went to the point na pinakat natin tong components na to our suppliers, no? And we found out na, ayan, meron palang gap, no? So, when there's a gap, no? When there's a gap here, so what happens? The tendency is yung product natin, nililift niya. So when it's lifted, that the deformation happens, no. So what is the root cause? So the root cause is itong screw boss na to is out of specification, is out of specs pala. Meron palang issue, no. And then we feed back to the supplier. So I feed back to the supplier, and the things has been resolved. So ayun, nakita niyo paano yung mag-provide ng value, no, sa company ang isang mechanical design engineer. So before pa nang ma-introduce sa market, so marami ng test na ginagawa. So tinatawag dyan is front loading or front-end engineering. So behind the scenes, napakarami na palang ginagawa or activities na nangyayari. So it's not only yung CAD. Remember, it's not only yung CAD. That is only a tool, but gagamitin nyo yung mga creativity nyo, yung technical knowledge, imagination, and even yung mga hands-on skills ninyo. So when you enter product development industry. Okay. So far, medyo mahaba. So do you have any questions? I'll entertain question muna. So kung meron, kung wala, I'll proceed na to the next topic, no? Okay. Okay, so part 5, no? Part 5. So this is main na lang to. Sharing my experience, no, sa industry na to. So what will you experience? What are the opportunities and challenges? Okay? Let's now start. So nabanggit ko na kanina, so what you may experience in mechanical design, focus, no, sa product development, no, industry, no. When I say product development, yan ang mga sa modules, no, yung mga sasakyan or even consumer electronics, no. So you will do the detailed design, no. So kung mahilig kayo sa designing, mostly kasi desk job ang pagiging mechanical design engineer. So you will spend majority of your time, no, in front of your computer. So you will do drawings, as I mentioned, and you have to collaborate, no. You have the design reviews, no. Kung yung team ninyo is a cross-cultural team or international team, you will have to conduct design reviews with, for example, North America, Europe, China, Japan, or even sa cross-location nyo siguro sa Pilipinas, no? And then you have to perform design submissions, no? When I say design submission is parang rushing yan, or it depends on you. Pagka last minute may schedule ka na i-meet, no? So you have to tawag nito everything has to be on time, no? Keep within the schedules. And then design modifications, so you will have don't be discouraged if there are design modifications. So this is part of the experience, no, as a mechanical design engineer. Documentation, katulad na sinabi ko, napakarami, as in sobrang dami, no? Because you have to document everything that you do. yung mga test mo, yung mga evaluation reports, yung mga design reviews, even yung mga part list, no? Everything. No? Ano pa ba? And yung, yung mga simulations, reliability test, and so on. So yung mga on-site visit and trial, pupunta kayo usually pagka-designer kayo, pupunta kayo sa tawag nito sa mga suppliers or even sa mga production site ninyo. Yeah. Okay? So may opportunity to travel. No? So pagka napunta kayo sa industry na ito. Okay? So just an example. No? So ako, for myself kasi ang expertise ko is plastic and metal. No? So pupunta kayo sa mga suppliers, sa mold injection trial. No? So ito yung examples sa mga mold and tooling. So you have to check yung mga tooling. No? So many times no, hanggang hating gabi kayo magte-test dyan. So just to check whether everything is in your design specifications and as per quality. So this is an example. So it can range to 80 tons to 2,000 tonnage na malaki. Just to give you an insight kung gaano kalaki ito, minsan kasi laki ng bus eh. So mas malaki pa sa bus, no? Yung ano nila, yung injection machine. No? Iba naman sinlaki ng mga tawag nito, mga desk. Anyway, malaki talaga siya, itong injection machine. No? So just be careful kung papasok kayo dyan. So it's a very risky job, no? Itong on-site visit. So what are the opportunities? Katulad yung binanggit ko, no? You have the opportunity to visit local suppliers. Ako, napunta ako ang first job ko is, nagpunta ako sa mga different suppliers sa Metro Manila, sa Southern Luzon, North Luzon, no? Doon ko natutunan yung mga actual industry practices. No? And then, I also had experience visiting overseas suppliers, no? Sa Korea, South Korea, Japan, China. No? So, doon ko natutunan naman yung parang mga fabrication. You have to communicate with them. No? So, through verbal and non-verbal. No? So, drawings, yan. Then you also have the chance to collaborate with overseas colleagues. So ibig sabihin, for example, sa US, for training certifications, pwede kayong magkaroon ng mga certificates, so for additional knowledge, and overseas training. No? Usually pagka yung maganda yung napasukan yung company, papadala kayo sa overseas, sa mga mother companies niyo, for example, 3 months, 6 months, or even up to a year. No? As a cadet engineer, magkaroon lang kayo na siguro ng binding contract to stay with the company, sometimes 2 years, and 1 year, 3 years. But I think it's worth, no? It's worth naman yan kasi they invested in you to gain those knowledge, no? Saka yung mga skills. No? So I think it's just fair na magkaroon ng mga bonding or binding contract. No? And then you have a chance to supervise different set of team of engineers and professionals. And you can also have a chance to manage a section, department, and even lead or drive a business or company. Okay. Ito yung sa akin. So, katulad ng sinabi ko, business plus leisure, di ba? Nung bata pa tayo, so I think 18 years ago or 15 or 16 years ago, so I had a chance to visit Japan, sa headquarters namin, to do design or co-design with Japanese colleagues. Ayan, so more on desk job lang, no? Just desk job talaga yung mechanical design engineering. Pero may chance ka rin naman pumunta sa suppliers. No? So pag pupunta ka ng suppliers, you'll have to commission, no? Or check mo yung mga tools or molds, no? Whether it is up to the specification. So pagka may nag-design ka, usually ikaw rin yung pupunta sa suppliers. Kasi ikaw yung nakakaalam ng mga very minor details. No? Ayun, so design, may chance ka mapunta sa overseas, co-design. Pagka naman nagde-develop, pwede ka rin mapunta sa visit with your suppliers, no? Which is very frequent. Depends sa company na mapupunta. And then kung later on, pwede kang mapunta sa mga customers, no? So, ito ay before the pandemic sa Japan. So while do customer meetings, after customer meeting, ano lang, ano lang, ikot-ikot ka lang dun sa area doon after nung ano, syempre, after work. So, ayan. Again, it is, napunta ako sa iba't ibang countries because of being a design engineer. So ako nga, OFW na ako, no? So I've been in Singapore for 14 years, pero OFW na ako, na nag-OFW pa. So meaning to say is, napupunta pa ako sa iba't ibang bansa, pinapadala ako ng company ko para mag-design or mag-develop or makipag-meeting sa mga customers or even clients or suppliers. No? So marami opportunities. So these are the opportunities. Ano pa ba? But of course, may opportunities, marami ring challenges, di ba? So maraming challenges. Di ba? So meron tayong problem solving, di ba? So meron mga hindi straightforward. Not everything is a bed of process, kumbaga. So may mga dinidesign tayo na hindi matutupad. Ngayon, doon na lalabas yung resolve mo. So how do you rise to the challenge, no, kumbaga. So you have to grasp, so marunong kang problem solving, root cause analysis, and yung solutions. So you have to provide solutions, and you have to may mga demanding management na hindi natin maiiwasan yan, di ba? May mga management will be very demanding. So because syempre business yan, business related, di ba? So you have to learn how to manage that, no? Yung boss, no? Difficult boss, and also difficult colleagues, no? Hindi maiwasan to. So let's just be real, no? So may mga colleagues tayo na we will not get along, pero you need to manage, no? You need to manage them. Even yourself, you have to manage yourself. How will you communicate? How will you present yourself, no? Again, it's up to you. How will you learn how to develop these people skills, no? And syempre may management, may difficult colleagues, meron din difficult customer demands, no? And supplier challenges, no? So it's how do I say, lateral, no? Top down, a lot of challenges. So top down meaning customer, management, lateral is your suppliers and colleagues, and even your subordinates, no? Pagka meron na kayong mga tauhan or mga members, no? That is also a challenge, no? How will you overcome those? It is up to the individual, no? But I suggest to gain experiences, people management or technical skills and soft skills, no? Overtime work, so nabanggit ko, so it is not pag-design mo isa na may mga problema, so sometimes you have to do overtime work to achieve those schedule. Okay. So some career advice from me. So what you should expect prepare before graduation. So you need to have a solid academic foundation, okay, which I believe you have, okay. Technical skills, so lahat ng binanggit ko kanina. So try to check, no? Meron na ba ako nito? Pag wala, fill up those gaps. People skills or soft skills, no? For example, no? Yung mga leaders dito, ayan. Leadership, communication, proactiveness, people management, and marami pa, no? Yung conflict management, marami pa. So actually mas malayo mararating nyo pagka na-develop nyo itong soft skills or people management, people skills, no? And ano pa, try to be involved sa mga school projects, no? Or para magkaroon kayo ng experience. Kasi sasabihin, gusto mo mapunta ng design, so pero wala kang experience. So how can you gain experience even without experience, kumbaga, sa actual or sa industry? So you can do that sa school projects, no? Sa school projects, pwede yung simulan sa grupo-grupo, o gawa tayo ng mga ganito, design tayo ng ganito. That can be one. That can be pagka nag-apply kayo, pwede nyo yun, ipakita nyo sa portfolio ninyo. Okay? We have designed this, at least gamitin yung methodology na pinakita ko, and then ma-impress na yan. Okay, meron na tong knowledge. hindi na siya start from scratch o back to zero, di ba? Baga, meron na kayong kickstart o head start sa iba. Okay, initiative design and thesis. No? Kung sa design or thesis ninyo, napalinya kayo sa product design, well, that can be one. No? That can be an advantage. Actual laboratory, dun sa hands-on. No? So dapat marunong na kayo ng mga simple drills. It is helpful no? Pagka alam yan. Mga training seminars katulad nito. At least magkakaroon kayo ng awareness. No? Actual work, kung meron kayong on-the-job training. So I'm not sure kung pwede na ngayon dyan sa Pilipinas, no? Pero dito sa Singapore, meron mga on-the-job training. So 6 months sila. They are shadowing yung mga mechanical designers. Minsan talagang binibigyan na sila ng design works, no? And even yung mga nitty-gritty, mga pagtetest, pag-measure, inspect, no? At least pagpasok nila sa trabaho, hindi foreign sa kanila yung gagawin, plug and play na sila na tinatawag na. Ibig sabihin is kung mag-start man sila ng trabaho, mas mabilis na silang aangat or makaka-get away no, sa mga task na. Or not get away but makaka-fulfill or makaka-gawa ng task. Okay? And networking and school activities, nabanggit ko. So you have to network with faculty, co-students, pati sa mga katulad namin, sa mga engineers and yung mga fellow students na. Okay? So I hope meron kayong napulot dito. And what you should expect after graduation, no, is, number one, syempre, is yung job hunting. So job hunting, I suggest ngayon pa lang magsimula na kayo. No? Kung ano yung gusto ninyong relevant industry. So maaring iba ayaw dito sa mechanical design kasi actually baka mag-work kayo. Meron naman gusto sa action, ma-action. Dapat nasa field or nasa industry or gusto yung mga nasa mas detail, mga ganyan. Depende. So depende sa inyo. At least this simple webinar can give you some insights. No? Ano yung yung expect. No? So tailor, kung gusto niyo sa mechanical design, you have to tailor your resume. Pag sinabing tailor, ano niyo siya? Kailangan niyo siyang i-update or modify, no? Kung papasok kayo sa mechanical design. I suggest huwag kayong maggawa ng generic CV kasi kung talagang gusto niyo mapunta sa isang industry, dapat ipakita niyo na tawag nito. Pero kayo ng skill set na yan. Maaaring yung marami kayong ilagay na skill set pero hindi naman pala siya tugma dun sa gusto niya mapasukan, is no point siya. So it is useless, no? At least in my view. No? So again, tailor your resume or CV dun sa industry na gusto mo. Okay? Interviews, negotiation. Don't expect, no? Real talk, don't expect na makakuha agad ng trabaho sa first interview. Kasi ang mangyayari dyan, hindi mo pa alam. So, pero ang pwede mong gawin is research mo talaga yung yung company, no, na mag-interview ka. Dapat you need to know yung papasukan mo. Nangyari din sa akin dati, pag sa sobrang dami kong ina-applyan, di ba? Hindi ko na alam saan pala yung mag-interview sa akin. So, lack of time, pero dapat ang gagawin mo dun is mag-research ka, ask questions, no, to your interviewers in negotiations. And then, as you go along sa every failure, not failure, ibig sabihin unsuccessful interviews, use those to update or enhance pa yung sarili niyo. Kasi example, hindi ko nasagot dito. And next time, pag tinanong na, alam mo na yung sasagot mo. Hanggang sa dumating yung point na bawat tanong sa iyo is automatic na. Alam niyo na yun. So yun yung purpose nito. And learning while we're working, so be open. So bibilisan ko na hiring process. So during interview, if possible, no? Siyempre, fresh graduate, di ba, wala pa kayong parang may papakita, di ba? So maglagay kayo ng mga personal design portfolio. So school projects, yun ang parang bala ninyo. At least parang prove nyo sa employer nyo na I can contribute, so you can contribute. I can provide value para mapapakita mo, no, I am valuable to your company. I could contribute to your company through this, and this. No? So para mapakita mo sa design portfolio. So even your personal hobbies, no? Kasi yung personal hobbies mo, sometimes you can tie it up dun sa passion mo. So example, yung passion mo is designing. So meaning to say, easy na sa'yo mag-transition sa designing sa work. Kumbaga, para mas madali na nga. Yeah. So solving problems and designing certain mechanisms. Okay? So browse mo yung JobStreet, JobsDB, LinkedIn, and others, no? As early as today, especially those sa mga graduating students. No? Huwag nyo na hintayin na after ng board, saka pa lang kayo mag-target ng industry. Okay? And yan, final note, medyo humaba. So my call for action is go for gold. No? So always go for gold. Yeah. What does it mean? No? So give your best, no? In what you do. That's G. So lahat lang ng gagawin mo. Just give your best. No? Lahat naman yan makikita ng boss mo, no? Boss, colleagues. No? It will surface, no? Without asking for anything. Just give your best. No? And then, pag binigay mo yung best mo, so wala kang doubts, wala kang parang, paano kung ginawa ko to? Wala kang parang tawag to yung panghihinayang. No? So just give your best in everything you do, and then let the rest follow. No? And then open to new experience, learning, and continuous personal development. So engineers tayo, but we have to be open to learning. No? So, example sa mga operator, even sa mga colleagues natin. So pag napunta kayo ng production, no? So manufacturing, meron kayong mga operators, so, or mga members, no? So sa production line, no? Matuto be open, no? So walang namang right or wrong, just be open to everyone, and that will provide insights and knowledge, no, sa sarili mo. And then continue to be continue to develop yourself personally. And leadership and professional growth, no? As you go further sa career ninyo, remember na to develop your leadership skills and professional growth. So paano to? So you have to attend seminars, no? People management, you have to upgrade yourself, yung professional mechanical engineer, a CN engineer, marami, no? So, mga Lean Six Sigma Green Belt, whatever, na makita niyo mga certification dyan. Because that will add value, not only to your company, but sa sarili mo talaga. No? So transferable yan, transferable in every industry. Okay. And lastly, determine your own path and career direction. So pinaka-importante, don't let others dictate yung yung kung saan kayo pupunta. So kung example, gusto ko dito sa field na to, pero merong may nagsasabi, huwag ka dyan pupunta. So determine your own path. No? So kasi ang mangyayari dyan is magkakaroon ka ng parang panghihinayang. Paano kung nagpunta ako dito? Paano kung tawag nito, ginawa ko to? So meron kang mga reservations. No? So determine your own path. Even sa career ninyo. So huwag niyo iasa sa boss ninyo na ipopromote kayo. So you have to be proactive. So gusto nating ma-promote, we need to be strategic. No? So we have to perform. No? So sometimes kasi hard work doesn't mean you will get promoted. No? So you have to be you have to determine your own path. You need to have strategy. How can you be promoted, or how can you move ahead with your career? No? So yun ang ibig sabihin kung determine your own path. No? So huwag nating hayaan na iba yung magbigay sa atin ng direction. So at the end, this is our career, this is our life. No? So we need to be, ang tawag nito, tayo ang boss ng sarili natin. No? Okay? So yung ganun na lang siguro. Okay, so go for gold. So give your best in what you do. Open to new experience, learning, and continuous personal development, leadership and professional growth, and determine your own path and career direction. So yan ang message ko sa inyong lahat. So thank you very much. So again, I am Engineer Adrian S. 𝐿 II at your service. No? Thank you. And I'm open for questions if there is. No?
So maraming salamat po, Engineer Makasakit, for that powerful ending that you gave, the go for gold. That is truly inspiring and motivating as well. And sir, we would like to say thank you and for imparting your knowledge and for continuing to inspire students like us. And to show our appreciation, may I call on our Vice President of External Affairs of the PSME DMMMSU Student Unit, Ms. 𝐼𝑛𝑑𝑢𝑠𝑡 𝐷𝑒𝑣𝑒𝑙𝑜𝑝𝑚𝑒𝑛𝑡 to give the certificate of appreciation. VP, please unmute.
Pakishow ako nung certificate, admin. Ayan, okay. Okay na. As our way of giving thanks for accepting our invitation as the speaker for today's webinar, we would like to give the certificate of appreciation to Engineer Adrian S. Makasakit in grateful acknowledgement for imparting his invaluable insights and worthy presentation as a speaker on the topic of mechanical design in product development industry, a prospect career of 4 innovator engineers international webinar organized by the Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University Mid La Union Campus Student Unit on February 20, 2022. Signed by President PSME Student Unit John Abel Ardelizo, our advisor PSME Student Unit Engineer Telma T. Obilio, our advisor COE SBO Engineer Sherwin L. Mosomos, our program chairman ME Department Engineer Melcar A. Miana, and lastly, our Dean, College of Engineering, Dr. Lorenzo L. Bacali. So, we have learned a lot of things from this webinar. Sir, kaya maraming salamat po sa opportunity na to that would surely nurture us and help us in our future mechanical engineering related endeavors. So once again, thank you so much, Engineer Adrian S. Makasakit.
Thank you very much. I hope marami kayo natutunan.
So once again, thank you, Engineer, for that, for your knowledge to impart it to us. And before that, can I invite everyone to please open up your cameras for us to have a picture taking with Engineer Makasakit. Right, so can you please open up your camera? Right, so let's see. So ito na yung final natin na picture taking, guys. Okay? So this will be the final one. So as I said, mas creative yung picture. All right. Okay, isa pa. 1, 2, 3, smile. All right, so isa pa po. Okay, so 1, 2, 3, smile. And for dalawa pa po. So 1, 2, 3, smile. All right, and for the final picture, 1, 2, 3, smile. All right. So thank you to our students and thank you again, Engineer Makasakit, for your presentation for today. Okay, so thank you students for cooperating in the picture taking. And now, before anything else, the giving of the post-evaluation form will be available in the chat box. So please fill it up. So ito na po. So it will be posted in the evaluation, in the chat box below. So please fill it up. So yun po yung magiging attendance po for today's webinar. And again, that will be just an attendance. And for you to receive your e-certificate, you have to like and follow our FB page and subscribe to our YouTube channel. And that being said, yung ating evaluation form na po is available in our chat box, and in the screen shown, this is our FB page and our YouTube channel. All right, and yes po, may nakabantay po sa aming FB and sa aming YouTube, so you're guaranteed na makikita po namin ang inyong pag-support po sa Junior PSME La Union chapter. All right, so moving on sa ating to officially close our event. Let us welcome.
Sorry, wait.
Yes po.
Okay, before anything, I just want you to give you guys, because you're young, you need to learn, katulad sinabi ni Sir Adrian. If you're going to building design, it's more advisable if you will go for Revit. Okay, you study Revit. Pwede ba mag-share? 5 minutes lang to. 2 minutes lang to. Ganun. Okay. So, tingnan nyo to. So, napag-usapan natin ito kanina. So, kunwari, hindi nyo ma-visualize yung kanyang design, you might going for around duct routing. So if you can see here, kung visualize mo lahat yung 3D, kanina din natin na gawa. So habang si Sir Adrian ginagawa ko. So nakita nyo, so medyo pa-slope kasi siya. So kasi yung kanyang ang design ng bahay is ganyan. So kung medyo regular shape yung mga design ng architecture, walang problema because mabivisualize mo and makikita mo kung paano yung ruta ng routing ng ducting mo. So at least dito makikita mo siya. Ayan. So at least maano nyo din kung yung kuwari magme-maintain kayo, paano nyo ipapatong yung ladder para maabot nyo yung fan. So lahat na ito kailangan maganda kung marunong as bata kayo. You will start from scratch. Maganda kung matuto kayo ng mga katulad na sabi ni Sir Adrian, skills, new skills, skills that you can be used and it can be an advantage when you go for your first job. So yun, sana ito lang share ko lang. So tsaka ito yung ginagamit sa abroad. So kumari sa totoo lang ang gagaling ng mga Pilipino sa labas ng bansa ng share ko lang. So ito yung MRT depot, pinakamalaking MRT depot sa Southeast Asia. Ginawa lang to, 3 kilometro to. 3 kilometro. MRT depot siya sa baba, bus station siya sa taas. So 3 kilometro to, ginawa lang ng 6 na Pinoy. So yun, nakikita niyo siya, napakadaming elements sa baba. So yun. So sana ma-encourage kayo, ma-boost yung kanyang moral na hindi na kaya ng iba, mas kaya ng Pinoy. Mas magaling pa. Okay? Yun lang. Sana ma-inspire kayo. Okay. Nakita ba yung ito? Nakita ba yung screen ko? Navisworks? Ito madami okay. Yeah, okay. Yeah. Tsaka yung mga Pinoy na gumawa niyan, yung isa nasa New Zealand na kasi na-pirate. Kasi if you have the skills, you'll be marketable and then you can go anywhere. Yan lang.
All right, so thank you. Thank you po, Engineer Arriola and Engineer 𝐿𝐴𝐻𝐿 for the knowledge that you have imparted us. And now for the closing remark, may I welcome our La Union Chapter President, Engineer Naldo C. Pipito for the closing remarks.
Good evening, everyone. Klaro ba yung reception ko dyan?
Yes po, sir. Good evening po.
Okay, good evening. First, I would like to congratulate the PSME La Union Junior Chapter officers and members, as well as the BOD for the successful interactive webinar. So I listened to the speakers. So second, I would like to thank the speakers, Engineer Klaus and Engineer 𝐿𝐴𝐻𝐿 for the very good presentation, very good learning process that you have shared to the students, not only La Union students. No, I think this is entire Philippines. So just bear with me for a few moments as I wrap up the topic that were discussed today. So these are very good technical skills improvement. However, we have to couple this with good behavior and attitude. So I believe Engineer Klaus and Engineer 𝐿𝐴𝐻𝐿 are in Singapore because not only of their skills, but also of their soft skills and behavior. So that's why I'm going to recap some technical and some behavioral aspect of the presentations. So number one, safety. So it always starts with safety, analyzing the hazard of everything that we do. This was mentioned by Engineer 𝐿𝐴𝐻𝐿. No? Second, simplify or simplicity. So this is the trend. We have to have quick decisions, and that rebate concept of Engineer Klaus is very, very good, very, very important. Third, plan, preparation, execution, and after action. This is actually the PDCA process, the plan to check act. There was a lot of problem solving mentioned. So this alone is a very broad topic, problem solving. So from Ishikawa, YY analysis, Apollo RCA, analytical troubleshooting, fishbone analysis. There's a lot of that if you want to learn. So your attitude will determine that. If you want to learn more about that, Engineer Klaus and Engineer 𝐿𝐴𝐻𝐿 have given to you their access if you want to learn more with regards to problem solving. Challenges have been mentioned, but let us remember in every challenges, as young engineers know later on, challenges comes with opportunities. So let's see what are those opportunities with these challenges. FMAA was mentioned, failure mode effect analysis. So this is also a very big topic on reliability analysis. So this is one aspect that we have to know also. Kahit saan tayo, sa manufacturing, sa design, this concept of FMAA will always appear in the horizon. Then the engineering economy. So everything that we do, it involves cost. And we should be able to think like a businessman. So we should have that value of entrepreneurial mindset. Everything that we spend, there should be value. There was also a mention of BOM, total cost of ownership, and the soft skills, negotiation, leadership, presentation, collaboration, communication, proactiveness, initiative. We have to start all these soft skill, all this leadership skill today at school. Because later on when you go to apply for a job, these are the big things. Technical, yes, but you can learn that. Sabi nga ni Adrian kanina, Engineer Adrian, you have to really improve your soft skills, especially on leadership, on collaboration, communication. These are very important because the interviewer will see this from you. And if you have this soft skill now at school, put that in your resume, and surely that is one of your main weapon to be accepted for a job you like. And then trial run, industrial run was mentioned, but at most the quality. Let's ensure that whatever we do in school or in the industry, there should be that quality. And last, to management of change. Later on, you will hear management of change and how are we going to adapt to the change. I think that's all. Thank you very much for the time that you have given to me. And once again, I would like to thank the student and the speakers who make these things, this webinar happen. Thank you.
Thank you po, Engineer Pepito. And yun na po ang aming wrap up for today. So thank you to everyone. Thank you to our engineers, our students, and to all of our guests that had attended in this national webinar for today. So maraming salamat po sa inyong patience and for your cravings for knowledge. All right. So magkakaroon ulit po kami ng future webinar. So that would be on February 27. Okay, ang ating guest speaker, ang resource speaker naman po natin is si Engineer Arriola 𝐥𝐢𝐥𝐢 with the topic of basic HVAC design, cooling load calculations. So we really hope yes po, sir. So we really hope na ang ating mga umattend po ngayon na ating mga students is mag-participate pa rin po kayo sa aming future webinars. And we really hope na nandun pa rin po yung support and yung craving nyo po for new knowledge to come. So another topic na naman po to that will challenge and will replenish, of course, sa ating pagiging kurso natin ng pagiging mechanical engineer. So yun. And again po, please fill up the evaluation form po. I-repost na lang po ulit kasi natabunan na po from the top. And that will serve as your attendance for today's webinar. And for, yun po, ulitin ko lang po ulit, for you to receive your e-certificate, please like and follow our FB page and subscribe to our YouTube channel for you to receive your e-certificate. And it will be released 1 week after this webinar. Okay, so momentarily, yung registration form po namin for this, for the future webinar, which is for the 7th national webinar will be open siguro po maybe tomorrow. Open na po yung registration. So yun po. Again, thank you for your participation and for joining us today. Okay, so thank you, students. And again, this is the PSME DMMMSU-MLUC Student Unit La Union Chapter signing off. Thank you po.
Yes.
Thank you.
Thank you po.
Thank you po.
Thank you.
Thank you, guys.
Thank you.
Thank you po.
Thank you. Thank you.
Thank you, Japit bukas.
God bless you.
Thank you.
Thank you po.
Thank you po.
Thank you.
Thank you.
Thank you po.
Thank you po.
Have a good evening.
Salamat po. Thank you po.
Thank you po.
Recording stopped.